Alright, let's do this. Let's get the music down. Alright. Hi guys. Oh yeah. Hi Jacob, Steps, Colt, Big Gravity, welcome to the stream. Master Blaster, Andy, Boca. Welcome to the stream guys. I'm really excited about this one. I've been dying to do this all week, so and hi Amok as well. Tonight we're going to look at software sprites, so let's just bring the game up where we're at so far. And while I do that, pour my glass of wine. I'm on the same wine again. I really like this stuff, so, and I'm only going to do one bottle tonight. I did drink quite a bit last night, so I'm going to take my time. That's good. Actually, before we start, I'm going to why am I not getting any control? Oh, I need to turn my joystick on. Oh, let me put the suggestions chat on as well, so I don't miss that. Go. Can you guys hear me okay? Okay, that's everything there. So, Foray has provided us with new map data. Actually, that's source tree. I don't want source tree. I want Charpad. So let's have a look at this. So what he's done is he's changed the colours around a little bit, which is going to help us with our software sprites. So now our multicolours are light blue and green, and our background is black. That gives us, the reason I wanted one of the higher colours, one of these here, is because you can't select them in the char colours. So it would have prevented us from having any of these high colours as a multicolour. So we've got that now, which means we can actually start mixing that. And I think actually Foray started doing that with these pipes as well. So everything in the background is kind of done in lines like this, which makes it look further back. So let me save out all this map data. Let me first of all save this project. Let's get to the right thing. Oh, I should be connected on Flubits, I think. Yeah, I am. Just let me know if it's not connected, and I'll do a push to GitHub in a minute with these files. Hi Akmafin, welcome to the stream. Let me close all my other things down that I don't need, like Steam. Okay, so let's save out this new map. I think it's just called Candy Map. Yeah. And we do need to load up this one because we need to copy these HUD characters out. So I'm going to do that first. So what we're going to do tonight is we're going to use some of this blank space in the char set to create. Why have I got a dot there? There we go. Oops. That character there. There we go. We're going to use some of this blank space in the character set to create software sprites. I'm just going to save out this character set, and then I will explain what we're going to actually do with the with the software sprites, how they're going to work. So let me quickly export all of these. I should have probably done this before we started, but it was kind of last minute. So chars, we'll just have to adjust the colours in the code as well so they match. Tile set, let's export those. Attributes. And the map as well. so let's just have a look how that looks. We're probably going to have to adjust the colours because they're going to be wrong now. Okay, so first thing we need to do is we need to invert these characters down here because they're no longer showing correctly. That's fine, that's easy enough to do. Just going to do that quickly. And I think it's in here somewhere, negative, there we go. And then we need to change the multicolours, which is, where did we do that now? Extended background colour, here we go. So our background colour is now black, and one of these is green, and one of these is light blue, and I'm sure this is going to be the wrong way around, so I'll probably have to do this again. Yeah, cool, that's pretty spot on. We do need to fill this area in here. I'm going to leave this effect in for now. I think it's fine. We'll leave that in, but we're going to have to fill this area in here with empty characters. I'm also seeing a bit of a glitch over here, but I can probably add an extra NOP in our NOP list. So let's quickly figure out how to do that. So we had another file, so save this one. And open up the HUD one. Why do we not have a HUD? Oh, okay. Disable the tiles, and now I need to import the actual HUD map that we made, which was this one, and it was just 3 high like that, and we'll create another character here that will fill in this area here, and this will just be an inverted character. So which it is already using that one, so don't need to do anything here. I just need to, I'm going to save this project so that I actually have the HUD detailed. I keep adding that extra block in there. I wish I wouldn't. There we go. So I just need to invert that one and make it white. Why is that not inverting? There we go. Cool, right, save all that out again. Just need to save the colours and the chars this time. I wish there was a button to do this all in one go, it's very frustrating. Cool, there we go, right, that should be pretty much the same state. Yeah, I'll push it to GitHub in a second, just confirm that it's correct. I'm just going to nudge this over as well. I don't know if you guys can see that, but there's still a little bit of a flicker in the corner down here. So I'm just going to push that across a little bit. So if you remember when we were doing the effect for the split, which was here, we used this NOP to push it out. I'm actually going to change this routine. In fact, I'll do it now. Why not? Because this is taking 11 bytes, so we can probably reduce that. So let me try something. So if we, so that's 2 bytes. So that's 5 bytes. And this is 11 bytes and using 22 cycles. So this is 2, this is 2, and this will be 3 every time the branch is taken. So we want 22, 2, this is 5, so it needs to do it 4 times, so that should be about the same. So all this is doing is just wasting some cycles by decreasing the X. Should pretty much do the same thing. Hopefully it's pushed it out to the side, and if that has, I'll push everything to GitHub right now. Yeah, it has, it's pushed it off the edge there, great. Yeah. I'm very well. I'm not concerned. I want to keep this down to 16K if we can. If we can't make it 16K, then fair enough. But we should kind of try and aim for that, because it'd be really nice to enter this into the 16K competition for next year. I mean, I realise we're starting way ahead of time, but it doesn't really matter. At least I don't think it does. I might have a word with James, make sure it's alright to submit this when we're done. It's probably going to take us to the end of the year to finish it anyway, so and I'm going to show, we're going to do, with the software sprites, we're going to create a table that's 256 byte long, but rather than store that in the code, we're going to use a piece of code at startup to generate it, just to save space, which is the sort of trick you need to do really when you do this. Okay, let me push that to GitHub. Thank you for the host, Hayes. Welcome to the stream. I did want to watch you last night, Hayes, but ended up when I got in I was quite drunk, so I just fell asleep instead. I'm having a lot of trouble catching up with people's streams now. Very busy all the time, unfortunately. Okay, so new map data with new colours. So yeah, I've been really looking forward to this. I've been thinking about how to do this all week. Got quite tipsy too. You got tipsy on the stream, did you? Good man, that's how it should be. Yeah, I've been thinking about how to do this all week, so let me give you a quick explanation of what we're going to try and do. So if you imagine our map like this, and we've got, in looking at how this works, so say we've got an element that looks like it's transparent there, so just think how to do this. Okay, so say this is a multicolor character, and we use multicolor characters to make it. We use only the multicolors to make it. And now we've got a green ball like this, probably make it like that to make it look a little bit more round. And we want to move that around the screen. So if you imagine, if I just turn off the tiles for this, yeah. So if you imagine putting this character on the map, at the moment we can only place this on a character, an exact character block. And that's not going to be any good for us, because that means we can only ever move 8 pixels at a time in any direction. So what we're going to try and do today, back to there, is we're going to try and use this blank space here, probably, so look, 1, 2, let's see how many we've got. So it will be in blocks of 4 characters, 5, 6, 7. So if we use all of these characters from here to here in this block here, that gives us 8 2x2 character blocks. And what that lets us do, if we store our bullet here, our projectile here, what we can then do is in these 2x2 blocks we can build up on the fly how we want them to work. So say I want to move it just 2 pixels across and 1 pixel down, I can do this. I think that's right. And now I've got a character that's moved over slightly, so, and I can do the same again on this one. And I'm not going to store them like this. They're going to be built on the fly. So we're going to do this as we require them. We're going to use this space to generate these on the fly. Which sounds more complicated than it really is, but I'm going to show you some tricks that make this easy. Because the other thing we need to do is not just... Sorry, I'm so slow at this. That's not right. There we go. It's not just put them in place like this, because now we're going to have a massive black rectangle around these things. But it's to actually merge them in with the background. So in this case, this would also have blue around it. So we have to calculate what goes around it as well to make it look correct. And that will have the advantage of, if we want to put this over a piece of background like this. Oops. I don't know how easy this is for you guys to see. Let's find out where that character is. That's this one here. Oops. Yeah, it is that one. Okay. Now we can start blending it properly into the background. So the way we're going to do this is, whenever you add a software sprite, it's going to be assigned an index. It's going to be assigned one of these. And what we'll do is we could go a few ways about this, but we're going to take a very simplistic approach, in that we're going to start our index here, and we'll just keep advancing. And when we get to them, we'll come back to here again. We won't do any first. We won't do any checks to see if the sprite is still being used. We'll just overwrite the previous sprite with the new sprite data. So if you try and create more than 8, then the oldest one will disappear, and you'll get the new one in its place. And then what we're going to do is we're going to work out where it goes on the screen, and then we're going to copy the data that's in that location on the screen into these locations here. So the first thing that will happen with this ball sprite, for instance, if we wanted to put it here, is we would end up with something that looks like this. But without that green blob on there. So let's scroll down so you can see it in a bit more detail. Gone all wrong now, hasn't it? Thank you for the host, Dom. Welcome to the stream. Hope you're doing well. You're another one I've missed far too many of your streams. I need to catch up. I need to get some time to actually watch you guys and catch up. Let me get that all lined up. I can't get it lined up now, why not? There we go. No, it's not right, is it? There we go. So we would create something like this first. So we know where the sprite wants to go. We're going to copy the data here, and then we're going to take this character and we're going to merge it into here using some clever tricks. Yeah, Hayes did really well on Nebulous, actually. He did far better than I can do on it, as I proved several times. Okay, so now we know how we're going to do that. Thank you for the bits, Real Thirds. And welcome to the stream. I've not seen you yet today. Oh, welcome. He used the level skip, but to be fair, he only used the level skip when he completed the level. So if he managed to complete the level, he skipped to the next one. I think that's perfectly valid to do while you're practicing, because he's going to speedrun it, right? Right, Hayes? Okay, so let's revert all of this back. So let's just open up the old map. So it sounds like quite a complicated thing to do, but actually it's not going to be that complicated. So we're going to reserve 8 characters. They don't have to be laid out in this character map like that. So we're just going to reserve 8 characters. So I'm just going to use this to mark out. We'll use this as our end marker, and we'll use the last 8 sets of 4 up to that point. So that will be 1. That'll be 1. That'll be 1. That would be 1. That's 5, 6, 7, 8. So our first character is at 187. So what we're going to do, we're going to create a new class. I think we'll put it in. See, really, this is a whole new subsystem. So we'll create a new folder. Did I actually push that stuff in here? I did, yeah. Okay, cool. what did happen? Did happen at the end? Oh, so we managed to get the scores changed for the little shrimp things. We managed to stop the timer when it got to 0, so it didn't kill you. It just stayed at 0, and we gave infinite lives as well. I mean, without the infinite lives, I think those changes are actually kind of quite valid changes. And I realised I think, Hayes, when you were reading about one of the bugs, there was a bug where if player 2 got an extra life, then player 1 would get 10,000 points rather than player 2 getting the extra life. And I could see in the code why that was the case as well. I realised after the stream that I could see where the bug was, because they were trying to be clever with the 2-player code. They were trying to be efficient with the 2-player code, and they overlooked the extra life. They got it working for increasing player 1 and player 2 score in the same routine, but they didn't account for player 2 getting an extra life. So that was where the bug was. It was actually a weird piece of code that had me confused when we first looked at it. I couldn't work out why they were doing this weird comparison with just one bit of the score. Okay, so we'll create a new folder. We're going to call it soft sprites, I think. And we're going to create a new file, and we're going to call this soft sprites. Soft sprites.asm. Okay. You know, I've used Sublime for years, and I must have pressed that please buy me now nag screen 1,000 times. It hasn't even occurred to me to bother buying it. Oh, that's a very good suggestion, actually. Actually, while we're on the topic of that, I think I'm going to alternate on the streams, on the Dissect streams. I'm going to alternate between... I'll just import this as well. I'm going to alternate between doing a single game dissection request where we go into detail, try and find cheats and such, and doing kind of an almost like explain this effect stream where I take a couple of kind of viewer suggestions and basically try and explain it. It can be from a demo or anything. We just some effects that people want to see, because sometimes there's an effect in a game and it probably only take 20 minutes to half an hour to explain it, but it would be a good idea not to waste an entire stream doing the rest of the game as well, but just to kind of blast through maybe 5 or 6 games or demos and have a look at those effects. So yeah, if you guys have got any ideas for that, then please drop a suggestion in my Discord channel. There is a dissect. There's a dissect request in my Discord channel. Let me just check. Yeah, dissect request. If you just drop some suggestions in there, and we can take a look at them. Yeah, exactly. That's exactly the sort of thing I'm thinking. Hayes, Creatures 2 Snow effect. I mean, I know how that's done, but I think it would be good to show people how it's done as well, because it's actually a very, very simple technique, but it's just done beautifully. So yeah, if you guys have got any suggestions, drop them in my Discord channel. That's not my Discord, that's my DII. There we go. Oh, also, look what got approved. And also... That's me squinting on tequila, so I thought I'd immortalise it. I've got a little bit of lemonade left. I'm gonna top my wine up with it just so my wine lasts a bit longer. I am only gonna drink 1 bottle tonight. Okay, so I've imported that new file, and the first thing we'll do is we'll initialize it here. So we'll do a soft sprite initialize, because obviously we don't want to start the game with sprites on screen. We wanna kind of keep it low. So, oh, thank you for the host, Tivan, and welcome to the stream. And Welcome to all those who are viewing through Hevan's channel. Hope you are well. Yeah, Hayes does have an emote for everything. Now we'll put that face on the barbarian figures. Please don't. Please don't. Yeah, welcome to the stream, everyone who's popped over with Hevan. So we're in the process of making a game for the C64. We're just about to start adding soft sprites into the game. Why is that not working? Oh, because it's soft sprites, not soft sprite. Where's my initialize? There we go. So rather than use the kind of the old technique of we don't have that routine yet either. The old technique of doing sprite multiplexing, we're going to go down a slightly different route and do soft sprites, because I think it's a good thing to teach. It's a good thing to share with people. Also, the way I do it may be different to how somebody else does it, so it's good for me to learn if somebody else has got a different technique for it as well. But yeah, we're going to add like player projectiles in using software sprites. Should be good. I'm going to take my watch off because it's actually run out of battery and it's pointless it being on my arm. It's just irritating me. There we go. Charbulous. I hear shower toppler. Shower toppler sounds like some really dodgy video. I don't think we should be doing that. Okay, so what do we need for software sprites? Right, we're going to need some variables. So the first thing I'm going to share with you guys is how you should store kind of large blocks of data. What I've seen a lot of people do is something like this. They'll have a data structure, something like this, and then they will create a set of bytes for each sprite like that. Say there's 4 bytes for each sprite, and they'll do that. So now they've got eight sprites with 4 pieces of data each, and then what they'll do is when they're cycling through, they'll take the kind of the first sprite and they'll load kind of sprite data plus 0 and use X as a thing to get the first piece of data like this to get each of the datas here, and then they'll use X to advance through the list. So they may have starting with this, and then when they go to the next sprite they'll either do that 4 times or they'll transfer it to the accumulator and add 4. And this is fine, you can work like this, but it is going to end up being slower. And the reason it's going to end up being slower is because you can't just take a random sprite index in the middle. So if I wanted to grab the 5th piece of data here, I've now got to take the number 5. I've then got to times it by 4 because I've got 4 bytes in it, so I've got to shift it 4 times. Then I've got to transfer it to here, and then I can get the data for that, and that's a really slow way of doing it. So the way I like to do it, and I think this is quite a common maybe there's called Tower Toppler in US, like the faces on the lollipops. Boys haul out the bear. Okay. The way I like to do it is I have a set of bytes for each individual property, and I keep them separate so I can reference them differently. So we need to think about what we actually want in a sprite. So we need to know, first of all, what the sprite is. So let's give it an ID. So this is kind of like our sprite pointers that we use. So this would be, for instance, 01 would be player projectile. 02 could be I don't know, anything. We can basically put anything we want. So what I'm going to do is I'm going to link that to our character here. Wait up, which one is? Oh, we don't have it yet. So we'll use these ones here. I'm going to put some dummy stuff in here now. Let's do it with multicolor. So I'm just going to put our little ball in here, and we'll use this for our test. So I'm going to store this ID. This is actually going to be the ID that we store. So 180 is going to be our player projectile. You'll see why that's important later. We can identify things by the character sprite. It just makes it a little bit easier. There's a little bit less code to do if we do it this way. So, right, what else are we going to need? We're also going to need to know that we'll copy this line because it's always going to be 8 bytes. In fact, what we can do, and this might be a neat way of doing this, is we can create a label for max sprites. We'll set that to 8. And then we can also create sprite fonts start, and that would be where we start in here. So at the moment we're starting here, which is at character 187. And then instead of doing this, we can use the fill command. So we can use fill max sprites with 0. So now if we change the number of maximum sprites, it will change the number of bytes in this list. So we need to know the X position. Yep, we need to know the Y position. Now the X, I think we should store the X and the Y as 16-bit numbers. So I'm going to store like this. We're going to obviously need 9 bits to do X anyway, because X goes up to 320. Actually, we don't need it for the Y, do we? We just need it for the X. Let's just do it for the X. We can always, if we want to make it more granular like we did with the player, we can do that later on. But for now, let's just get it working with this system. So we're storing a 16-bit number for the X position, an 8-bit number for the Y position. That gives us any position within this map at pixel granularity rather than character granularity. And we know what we're going to draw in that location. That should be enough for us to start with. So let's start with that. So the reason I put this initialize in is because when we restart the game, once the game's been running for a while, we want an initialize to reset all these values. They'll start with 0 because that's what we're poking into those values at startup. But if we need to refresh everything, this initialize is going to act as our clear function as well. So we just call initialize and it will reset all of these. So we'll do that by getting the value 0. Let me just have that over a bit. Do like my labels to indent properly. And we'll store that at these locations. And you see now I can very easily see I'm grabbing the ID, I'm storing it for the first index. You know, it's much easier than doing it with one big table and trying to work out what each bit of the tables, where each different index starts in the table. This is a much simpler way of doing things. And for something like this, where we're going to be doing a lot of operations on these values, it makes sense that we can grab them really quickly. Increase X, I'm going to compare it to max sprites. If it's not equal, I'll go back to there. So now all our initialize is doing is clearing all these values. So we're going to need an add sprite. We're also going to need current sprite index. So as I said, we're going to start at index 0. So this is going to start at 0. And we're just going to advance through the sprites until we get to the end. So we'll store that here as well. And when we get to the end, we'll wrap around each time. I'm not sure what that is. I don't know if I should click that. I'm going to click it because it's up there. So it's a JavaScript joke. Yeah. Okay. Oops, where's my thing? Have I forgotten the tech channel? No, I've got the suggestions channel open. Is that what you mean? I'm not sure what you mean. I've got the suggestions channel open, so if anybody makes a suggestion in there, I should be able to see it. Oops, I'm losing track of everything here. I can't see. Oh, am I not? Let me refresh that page, then maybe I'm not getting something. Ah, there we go. Yeah, it wasn't updating for some reason. Oh, thanks for the host, Hitch. Welcome to the stream. Okay, so let's go through the stuff in there. So Step says, so for soft sprites, how many spaces in char set do you need to reserve for it? So it depends on the size of your software sprite. So we're going to use a single character like this. So our software sprites are going to be 8x8, but that means that they can, if they move into at least 1 pixel in each direction, they can take up to 4 characters. So we'll use 4 characters for each. For each software sprite. Would you use virtual for this? Does it save space in cars or 0 or initialized? If you put it in as zeros consecutively like this, when we ximize it, this will probably be reduced down to 2 bytes. So I'm not too worried about tables that are initialized like this. When you've got tables that are initialized with values that aren't just the same, then you need to start thinking about a different way of generating those tables. One thing I did on the .cosmos 1 to try and get it to all fit in was I actually moved all my tables into a single file, and then I organized the tables in that file based on the values that were in it. So if I had tables that were full of zeros like this, they would all be put together, so every single table that had zeros in it was consecutive, so they would be compressed into a single, into 2 or 3 bytes. So what Ximizer does is it, at the very basic level, it does run length encoding on things, but then on the run length encoded stuff, it does another compression algorithm on top of it as well. So if you can get bytes to be the same in a row like this, it's brilliant. It will help. If you consider all possible positions of the ball in 4 chars, it's going to be huge. Yes. So we're not going to generate. We're not going to generate up front the ball in each of these positions, because there's, well, what is there? There's 64 positions that this ball can be in within this block, right? Actually, no, not. Oh no, yeah, 64. So it's eight positions this way, and then 8 positions this way. There's quite a lot. So we wouldn't want to do that, because that would take the entire character set. So what we're going to do, we're going to build that on the fly. And the other thing is if we tried to do it up front, we wouldn't have the background blending in it. We just have a black rectangle with a ball in it. So what we're going to do is we're going to grab the data underneath where the ball's going to be, fill out the character with it, and then blend our ball on top of it. And yeah, so we regenerate 8 times. Okay, so would you want to page align the table so the index doesn't break a page boundary which is lower? Depends on your routine. So yeah, Andy's got a point there. If you're using an index routine like this and you cross a page boundary, then things get a bit slower. It takes an extra cycle to do these things. For this game, it's probably not that important. But if you did want to align tables, there's this function, this kind of meta thing in Kickassembler directive called align, and what you do is you pass it in a value, and it basically finds the next memory location that kind of matches this. So say our program counter here was at 5027, then using this align would actually move the program counter to that. If we were at 5327, it would align it to that. It just aligns it to the next 100 up, and that's useful for aligning these tables to ensure that you don't cross page boundaries. But for what we're doing, I don't think it's going to be too important. Okay, so we need to add a sprite. So what we'll do is we'll start we've got the routine here. It's drawn the map. We've initialized the sprites. We'll actually just put some debug code in here. I'm going to write debug, so I know I'm going to remove it eventually. And what this is going to do is it's just going to draw us. It's just going to add a sprite to the list basically, and we'll use the X and Y registers to pass in the locations. Is that going to be good enough? Because we need 9 bits for X. For now, let's do it like this. We can figure out how to change that later. So let's pass in a fairly kind of uneven value, like so. Something like that. And we'll use those values to pass it in. Yeah, the align command is really useful. It's more useful if you... There's different cases. So one case is to prevent indexes from crossing a boundary. So when you're using the comma X or comma Y kind of indexed addressing routines, they don't cross a boundary, because then when they cross that boundary, that actually takes 1 extra cycle to do that one. The other thing that they're really useful for is if you're using self-modified code, you can basically only just change 1 byte. So if you're doing a kind of an index thing where you're using comma X again, but you want to go up through several pages, you can just lock it to an index, and you can guarantee it's always going to be least significant byte at 0, 0, which makes kind of self-modifying a little bit quicker as well. Yeah, there's a lot of tricks with it. So I've done what you just mentioned for all the tables in a file with a macro, which I suppose they don't cross a boundary. Yeah, and it's useful to put all the tables in one file because of the compression as well. You'll see when you do Xmizer to compress the code, you'll see sometimes that even just kind of moving a function from one place to somewhere else in the file can have a massive effect on the compression. So if you are trying to make something and you're trying to fit it into 16K for a 16K competition, for instance, and you're a couple of bytes over, don't immediately think you need to remove things. Sometimes just shuffling stuff around can change the compression and give you better results. And one of the best things you can do is move all your tables into one file, get all the tables with the same values next to each other, and then the run length encoding can really crop them down quite a bit. And as you'll see, we're going to do a 256 byte table soon, but rather than build that table into the code, we're going to use a function to build it at runtime. Yeah, I use the online version. I use the HTML version. The PDF one annoys me because it's a bit harder to search it. I think the HTML one's really good. I'm not saying you can't search it, but it is just a little bit harder. Okay, so we want to add a sprite. So the first thing we need to do is we need to set the next sprite up. So actually, we're going to pass in that. So this is the sprite X. This is going to be the sprite Y. And this, which I've deliberately done in decimal because that's what I checked it in here. I could convert it, but when I click on here it says 180, so I'm just going to use it like that, is our character ID. So we're going to grab our current sprite index and we're going to store that in. We'll store it in Y. I like to use Y for these sort of things because I tend to use X all the time. So if I use Y for these, then I can continue using X right here, and as long as I don't change Y, I'll always have the right sprite index. It's personal preference. I mean, you can do it any way you want to. Right. So we know. Actually, I can't do that just yet because Y. I need to store y. So I've got x and y, which I need to store. So what I'll do is I'll just store y just for now into temp1, which is our 0 page temporary thing, which I'm going to split out over here actually. As my layout view, layout, 2 columns. Just stick that out. Oops. Oh, come on. There we go. This is only going to be used temporarily. I'm not going to alias it. There's no point. I'm just going to store the values that I need to. So first of all, I'm going to store the character ID, which is passed in the accumulator, and that needs to be this. So you can see how this is much easier now because we've got the value in Y. We don't need to kind of work out, okay, given this current sprite index, that's 12 bytes through the table. We can just reference things directly like this. Thank you for the follow, Vigo Master. Yeah, I did trash the Y, but that's why I'm storing it now. So the next thing I'm going to do is I'm going to load the Y from that value. So I'm immediately storing it, immediately grabbing it back again. Sprite data Y, and then I need to store the X. So we've only passed the least significant bit in. We have got a most significant bit that we need to do, but we've only got 3 variables. So what I'm going to do is I'm going to actually use the carry bit here. This is another trick you can use. I'm going to keep that alongside there. Is the X at least? Yes. Yeah. So, yeah, I'm going to use the carry bit here to do that. So, because the carry bit is just a single bit, and we only need one more bit to store it. So all I'm going to do is, if it's clear, it's a 0. If we set it, it's a 1. We don't do anything that's gonna. Why have I got that open? That shouldn't be open. We're not going to do anything in here until we use the carry bit that's gonna break that. So we can actually do it. We can do it straight after that. But I'm going to do it down here. I'm just going to do it at the same point that we store the LSB for the thing. So and the easiest way to do this, the carry bit is now 1. The carry bit is either 0 or 1. So I'm going to take the accumulator with 0 and I'm going to roll it to the left. So what that's going to do, if you imagine that's our binary for 0, and this here is our carry bit. When you roll, it shifts all these across by 1 and takes whatever's in the carry bit and puts it here. So if we pass in 0, if we pass in a clear carry bit, then it's just going to roll a 0 onto the end and this stays at 0. If we set the carry bit, then this will be 1, and when we roll it to the left, that now becomes 0, 0, 1. So rather than do some weird branching, we can use a quick roll just to set that value and store that there. So I hope that makes sense so far. There's a lot of chat delay. Yeah, I think my internet's not been too great of late, so I think it's kind of automatically sticking quite a long buffer on it. I'm not sure why. Probably because it's Sky and it's terrible. Let's put a bit more lemonade in. I'll stick a bit more in. Cool. So we've added that sprite now, and the other thing we need to do is we need to increment our current sprite index here, which we've already got in Y. So we'll increase Y. We compare that to our max sprites. If it's not at the max sprites, then we can just jump ahead to here where we will store it back into current sprite. so that the next one will be in the next position. However, if it is at max sprites, then we just load Y with 0 again. Is the carry bit set if any of the A, Z or X registers, or just the A registers? Yeah, if any of them, if any of them go over. But you tend to just use it on the A register more, so you can see that. I think it's any actually. Let me check. So you can check that quite easily on the opcodes list. So if you have a look on this page and you have a look at the increment X, no, it doesn't actually. So increment in the X doesn't set the carry bit, it's only the accumulator. So you can see there, inks sets the 0 flag and the negative, but not the carry bit. Same with those as well. The shifts will do it. I think it is only an accumulator thing, but you can set it by comparing X and Y. It's the sort of thing you kind of look up with these things, yeah. So yeah, if you compare the X, so if you load X with I don't know 32, and then compare it with 31. Oh my god, I can't even type. That will set the carry bit. So at this point, carry is set. Because the carry, whenever you do a comparison, if the value you're comparing is more than or equal to the value here, then the carry will be set. If it's less, then the carry is not set. But yeah, carry is something really I've only thought about in terms of comparisons and the accumulator, so that's why. If you want to check overflow after inks, just check Z instead. Yeah. Yes, loading and storing will not affect the carry flag. It's only when you do increments, so additions and subtractions. In fact, I don't think even ink and deck do it either. Let's have a look. Ink and deck. That sounds like ant and deck. That's kind of worrying. Yeah, ink doesn't do it either. So none of the actual increment commands do it. But shifting the accumulator, so this can set the carry bit. It also uses the carry bit, as can that, and that. All of those commands can affect the carry bit. Addition and subtraction affect the carry bit, and comparisons affect the carry bit as well. Yeah, so if you load the accumulator with 0 and then do a roll to the left, you basically load the accumulator with the value of the carry bit. So this is a sneaker, because otherwise what you'd have to do is you'd have to kind of do, okay, load accumulator with 0, branch shift carry clear here. So that does the same thing, but obviously this is a little bit more inefficient. This is just a more efficient way of doing it. I'm doing it in like 4 cycles instead of 6 or 7. Okay, so now we should have, every time we add a sprite, this should increment by 1. Our data should get stored in this table. And that's all we need to do for add sprite. The next step is to write a draw sprite routine, and this is where it gets a little bit funky. So we're going to do this in stages. Yeah, or add 0. Yeah, so you could do a roll like that, or you could do that as well. That would also change it. That's one less byte though. But yeah, Furrow's right. Oh, pardon me. Shouldn't mix lemonade with wine. It makes me burp. But yeah, Furrow's right. That's another way that you can grab the carry bit as well. So our draw sprite routine needs to go through this list, through all the indexes, checking to see if the sprite ID is set. We'll treat this, if it's 0, as an inactive sprite. If it's anything other than 0, we need to draw it. And then it will draw that sprite on the screen based on this font start here. And so what it's going to do, actually let's just call this function in, let's call it draw sprites. We'll just return from it, and we'll just stick it in our loop here. Or sprites. There we go. So now it's going to be called every frame. So we need to go through all our sprites. So we'll start at position 0. We'll create a loop like this, and at the end we'll compare to see if we've reached max sprites, and if we haven't, we'll keep doing the loop. We need to add a skip label here, because first thing we need to do is load sprite data ID, y, and if it's 0, skip. So now this loop is only going to do this section here, whatever we put in this location here, if that sprite ID is anything other than 0. Is there an ID? I don't know operation. No, but you can make sudo commands with Kickassembler, so you could make one you want quite easily. So sometimes I do things like I might have that as a sudo command, and then that will just internally it will just do that. Or you can do things like so that is actually an illegal operation. So you'll see in here there's these illegal opcodes, and there is one called SLO here. So I might do something like that, and all that is doing is, and then my operand would be in here, like or something like that, and then behind the scenes that would do. I would just insert that into the code, but we'll go over that at some point. I don't think we're going to need them straight away, but you can make any old commands that you want. Okay, so we're going to do a very naive operation first. So we're just going to assume that our character is correct. It's already been merged into this location, so we're just going to grab the sprite that we need, and we're just going to draw it. So first thing I can think of that we're going to need is to probably make another table here, based on these locations, on these characters here. Let's just think, should we do that? Yeah, I think so. We can always build these programmatically if we need to, but for now, call it char starts. That should be enough. But for now, we'll just put them in here. So what this is going to do is it's going to be a little bit more complicated than the rest. It's not going to be full of zeros. We're not going to reset this. This is constants here. These aren't going to change, and it's going to be this start value here plus whatever index we're at times 4. And so that's going to create a table that's, in this case, it's going to be 187, 191, 195, 199, and so on, increasing by 4 each time. And you're going to need X and Y velocity for each, or is something about how long it's been alive. Yeah, so that's the sort of data we'll add later. Now we just want to be able to draw it. As soon as we can get them drawing on the screen correctly, then we can start thinking about adding more and more data, more and more functionality to these. There's no point keeping it in a separate place. We may as well add velocity data into here anyway. Yeah, so these constants, these are just going to be used to draw our sprite on the screen. So the first thing we need to do is we need to convert our X and our Y into screen space. Now, unlike normal sprites, our sprites are going to start exactly on a border, not behind the border. So with sprites, they start over here. But with our sprites, 0, 0 is going to be there, so it's going to be a nice simple divide by 8 operation on both. So in fact, I'm going to go for a quick cigarette, so I'm going to take 2 minutes. Then what we're going to do, we're going to divide those x and y values by 8, and then we're going to draw these characters in that location. What we should see is when that sprite's been added, we'll see kind of probably just a black square where it's supposed to be on screen, and we'll do some tests just to make sure if we move it around on the screen it appears in the right place. So I'm going to take 5 minutes, guys, probably a little bit less than that. I'll be right back. Be right back, guys. That was a quick one. It's cold outside. I'm just in shorts. Plus I'm quite eager to get this done, so right, where are we at? Yep, so we've got a loop that's going to go through each of our sprites, and now we need to get the sprite data for X and convert it to screen space. So we're going to load, first of all we're going to load the sprite MSB, the hide byte of it, like so, and we're just going to shift that into the carry bit. So if it's 0, the carry bit will become 0, and if it's 1, the carry bit will become 1. And now we can load the LSB, and we roll that first to get the carry bit in, and then shift it twice. And so now the accumulator will be this value divided by 8, and we'll store that in. I'm going to create some aliases here, so we'll call it screen X, and that can be temp 1, and we'll have screen Y, which will be temp 2. So we'll store that in screen X, and then we do the same again for sprite Y, which is a simple 8-bit value, so we don't need to do any roll, we can just shift it 8 times like so. Cool. And cool, so now we've got the X and the Y. What we can do is we can then look up in a table. So we've already got this table because we generated it for our sprite collision data, which is this one here, and this gives us this position, the character right at the beginning of the row of each position. So we need to, using the Y value, which we've already got, so I'm actually not going to store that in there, probably don't need that. I'm going to leave that there, but we probably don't need to store it straight away. Instead, what I'm going to do is I'm going to transfer that to the X register, and then I'm going to load, what was it called again? Screen row LSB. No, not like that, sorry, like that. And that needs to be tables. And I am going to create do I have a vector? Yeah, I have some vectors here. So vector just means a pointer. It's a 16-bit value. So I'm going to call this screen row, and I'm going to store that at screen row. Now I need to grab the upper byte and store it at screen row +1. And now screen row contains the address of the beginning of this row. So what I can do, and you know what, I should have used the X register and not the Y register here, so I'm going to switch this over. I'll show you why in a second. It's my own fault. I was thinking far too far ahead. I didn't realise I was going to need this. So that should actually be transferred with Y. Should be Y. And it's because now I need to do well, I'll be storing a value at screen row, but indirectly indexing with y. And y is going to be this value here. And that should be that. And if I just load a random value into, if I pick a character in the character set that's gonna stand out, so like 144. Good night, Dom. Thanks for joining. I'm gonna catch up with your streams at some point. I hope you did well on your Airwall stream. I need to see what you did on the last one. So now this should, in theory, print our character, print a single character at the location we specify here. So let's have a look what it should be doing. So if we divide this by 8, we're going to get 16 across and 6 down. So we should see a character round about 4, 5, 6, 7, round about here, I would say. Hopefully it will just put a black square there, if we've done this correctly. And for some reason all the colours have gone funny. But it has put a character here, but our colours are all weird. I don't know why that is. Let's just turn off this for a second. When you say you killed, because I saw you said you were going to bury it, I kind of hope that you actually physically buried it. I think that would be really funny, but I do want to watch it. Actually, don't tell me what you did. I'm going to watch it. I need to know. So I will look up and see what it's done. That's weird. That just kind of... So I turned off this routine, and it fixed it. So let's try it again. That's really bizarre. Let's have a look what we're actually doing. We're getting the screen row. Oh, it's because of this. As I changed for X register everywhere and I didn't do it down here as well, that's all. I was about to actually bury it, but my camera went out to have beers, so I decided to make it simple. Okay. I'm still very intrigued. I need to know what you've done. Also, I noticed I've got the background colour wrong here. It's blue and it should be black, so it's going to do that. I'm still very intrigued. I still need to know what you've done, so... you shot it with a big gun. Okay. I really have to see that. Okay. I think that needs to be black. Cool. So it is putting our character here, but this isn't enough. What we actually need to do is draw a 4x4 block there, a 2x2 block there. And at the moment we're just putting any old number in here. We don't want to do that. So we need to place 4 characters here. So we need to do. I'll label them like this. So 0, 0, and we're going to start with, what was it? Screen. It's a char start Commodore X. So this will give us this character here. That character there, and we need to place that exactly where it is now. So in the screen row and the screen X that we specified. Then what we need to do is we need to increment that a little bit to do the next one. So now we want to do a cross by 1, and so to do that we're just gonna actually I'll do the clear carry bit here. Just find it a bit neater if I do it there. I know it's not going to go over because this is never going to be at the end of the character set, so this is fine. So I'm going to add one to this, so I get the next character. I'm not going to load the screen X because I've already got it. Instead, what I'm going to do is I'm just going to increment it, and then I'm going to store it there. So now what we should see is two characters there. A week of playing WoW Classic till 4 AM. Just finally called me. Yeah, no problem. I've avoided it. I've tried so hard to avoid it. I'm kind of glad that I have, to be honest. Yeah, good night. Good night. The VOD will be up anyway after the stream, and it'll be on YouTube sometime tomorrow afternoon. I'm really looking forward to getting my new build in November. I can actually compile these videos in half the time. I mean, this chip is good, but I think the new Ryzen 3950 is going to absolutely slaughter this i9 when it comes to compiling videos. I'm looking forward to that. Okay, so let's test that. So this is just going to create two characters side by side. Hopefully they're going to be these two characters here. We can, in fact, I'm going to export this to just as a test. I'm just going to write some numbers in here, just so we can make sure that it's putting them in the right places. I'll do it with the multicolour so that it doesn't clash with anything. So that's going to be 2, that's going to be 3, that's going to be 4. So okay, this is going to be 2. This one needs to be 3. And this one needs to be 4. That'll do, it's fine. I'm just going to export that character set. So I'm not going to commit this because this is just for testing. You guys that are following along on FluBits, you'll just have the character. You'll probably just have black characters, I think. Chat controlled lunar lander, yeah. Yeah, I'm still thinking about how to do that. I do want to get that working, but I don't think it's going to work on a Raspberry Pi, unfortunately. I tried, but I don't think there's enough power for it to stream from the Raspberry Pi. I'd have to have a computer on all the time, so I'm trying to find a better solution for that. But when I get that working, that's going to be a permanent fixture on my other Twitch account. I'll just be able to leave it on permanently. Okay, so let's try that. So hopefully now we should see 1, 2 here. Done this right, which we do. Perfect. So now it gets a little bit more complicated because we're moving on to a new row. So instead of adding 1, we now need to add 39, which is 27 thing, because we've moved 1 across. We need to go 1 row down, which is 40, but back 1 as well, so it's 39 we need to increment by. And we also need to increment y by the same value as well. So what I'm going to do is I'm actually going to push that onto this. Actually, should I push it onto the stack or no? I'm going to store this in a temporary. We're not using temp2, so I'm just going to call this. I'm just going to call it temp. I know it's kind of silly that it's already been used. And then I'm going to transfer y to the accumulator. I'm going to add 27, and I'm going to transfer it back. And I'm going to load the accumulator with temp again. There we go. So it's a bit longer, this block of code, but it's because we've had to go down a row. So if we run... I've just done that in the wrong place as well, haven't I? Damn it. I'll tell you what, just copy that. And do... Yep. That should have been there instead. There we go. So if I run that now... I think they all... Oh, okay. Thanks, Hayes. I wish I could do that automatically. You need something with an x264 and x265 hardware encoder, so there's no chance of encoding a high. So I've got a 2080 Ti, and I'll be getting a second one in my new build. but I'm actually finding that the CPU is better at it than the NVIDIA. If I use the NVIDIA encoder, it's about 20% slower than if I just use the i9. I'm not sure why, but maybe it'll be different with two cards. So, and I realise 2 cards is overkill, but I'm looking towards 8K. So as soon as the 8K monitors start coming out, I will be getting one. And so the last row, we just do what we did here. We add 1, we increase Y by 1, and we should get the same. So now what we should see is 1, 2, 3, 4. Actually, is that right? Yes, that's right, because it isn't add 27, it is just add 1. Because it's the character that we're incrementing, that's fine. It's this one that needs to add 20. So actually, I got this wrong and then corrected it with my undo. So we should see 1, 2, 3, 4 now, if we've done this right. Cool, and we do 1, 2, 3, 4. So I know now if I place a sprite somewhere on the screen, it's going to create a block of 4 characters in that location. So now the trick here is going to be updating these characters. So we need another function now, which is going to be this is our draw sprite. So I'm going to leave the draw sprites at the bottom, and I'm going to have an update sprite function. And the update sprite function is just going to set the X and the Y, but it's not going to do it. It's not going to do it by explicitly setting the X and the Y. It's going to add whatever's in the X and Y to the current X and Y. So if I get, let's see, I need to. Okay, let's think about this. Right, so I'm going to store this. I'm going to add the sprite, and then if I wanted to increment that sprite 4 characters across and 1 down, that's how far I'd need to move it. So this routine will be, actually I'm going to call it move sprite. That makes more sense, I think. Okay, so we need to take our value that's in X, and we need to add it to these values here, and we need to take our value that's in Y and add it to these values. So I'm going to start by just pushing Y into a temporary value again, because we're going to immediately start using, well, actually that's a good point, we need the index as well, so we'll treat that as the index, and we'll actually make this return the index in the accumulator as well. So actually wouldn't need to set that. So if you wanted to store the value of this particular sprite, you could store it in here, which we'll need later on. But for now, let's just do this. So where's our add sprite? Where is our add sprite? There it is. So this is adding the sprite. It's increments. So we're going to transfer that Y to the accumulator. So before we increment the Y, we're just going to transfer it to the accumulator, and then when we add it, it's after running this function, the accumulator becomes the index of this sprite. So we don't actually need that now. Music seems a bit higher than normal. It's on 37.3. I'll knock it down a little bit more. There we go. I think as well some of the audio, because it's just taken from a YouTube stream, and I think because they're just plain SIDs, some SIDs are louder than others for some reason. They shouldn't be really, but yeah, I think they are. So you'll probably find it seems too quiet soon, but it's fine, it's background music, it's not the focus of what we're doing. So okay, so we're storing the Y. The accumulator is our index, so we're going to transfer that to Y. I mean, we could do this differently. I mean, you could say, in here, you could say, okay, Y will be our index, and we'll pass A and X as our X and Y. But then it just, I like to use X and Y as X and Y. Otherwise, it's going to get confusing when you're passing these values around all the time. So it means we've got to do a little bit more shifting around here, but it's fine. It's a small hit. So the Y register is now our index, and we can load the value that was in Y back. So we've basically just swapped A and Y around. So the accumulator is now the value we need to add to this. So it's as simple as just adding that value. Clear the carry bit first and add it, and then store it back in here. That's the Y value added. If we wanted to add a negative number, we'd simply here we'd just use the negative value instead. So you know, that would be negative 20. Whoops. And now we just need to do the same with the X value. So we transfer the X to the accumulator, clear the carry bit, and that should be Y, not XMSB. Add that to there, like so, and that's going to be added to the LSB. And then we're going to store that in there. Now the carry bit will be set if we overflow, so now we can load the MSB. Whoops, did that copy? Yeah, it did. Load the MSB, add 0. If the carry bit's set, it will actually add 1, which is exactly what we want to do. We want to catch the overflow from the 8th bit and store that there again. And that's it. That's all we need to move a sprite around. So if I run this now, we should see, instead of the sprite being here, we should see it kind of over here somewhere and down a bit. It'll be 1, 2, 3, 4. It'll kind of be here, I think, somewhere. So let's do that. Yeah, there we go. So that lets us move it around. But what that's not doing, it's not clearing anything behind it. So if I was to start it at 0, 0 up in the corner here, and instead of doing that there, I did this per frame in here, for instance, and I moved it by, I do need the index now because I don't know what the index is. If I just move it by 1, what you'll see is it will just slowly kind of create a trail of those things across the screen. So our next job is going to be clearing what's behind, but I'll show you what we need to do to do that. You can see it is moving it, but it's kind of leaving junk in its trail. So the next job is to work out what was where that sprite is, and take that value and store it. So in our soft sprites in here, we're going to need how best to do this. Actually, I think the safest way to do this is not going to be remembering what's underneath, but just having a clear routine. And to do a clear routine, we're going to need to know what to clear it to. So normally if you were just clearing a screen, you would just clear everything to 0. But I think what we need to do is we need to take a copy of the current screen and store it somewhere else. So what we'll do is, in our map function, where we draw our map, in this function here, as soon as the map's been drawn, so at the end of this routine here, we're going to call another map loader routine, and this is going to be what can we call it? Let's call it buffer map. And so what we're going to do, we're going to assign an area of memory where we take an exact copy of the screen, and then we can use that for putting the map data back. So there's two ways we could do this. We could either do it this way, where we put the map date, we have a second copy of the screen and we put it back, or when every time we draw a sprite, we first record what's underneath it and store that somewhere.
that way is going to be a bit slower than doing it this way. And having a second copy of the map means if we've got two sprites that overlap, when the second sprite overlaps, if we were just using the copy what's underneath, it would copy the first sprite underneath that's underneath the second one. So when you remove the second one, it would draw the first one back. But if that one then moved and then you would lifted that off, you would end up with kind of shadows of the map behind. So you can do it kind of that way, but if you do it that way, you will end up with problems. In fact, I think it's the way Turrican does it. And if you look at Turrican, you can get into situations where bullets end up stuck. And the reason they end up stuck is because you've got lots of software sprites moving around the screen and they're trying to remember what's underneath them. That's not a good action. They're trying to remember what character was underneath them when it was printed. But if two are printed on top of each other and then the first one gets removed, when the second one gets removed, it's going to put the first one back again. And because that's just an incorrect kind of render, it's not going to move, it's not got any state, it's not part of the bullet system, it's just an incorrect clear, and you'll end up with kind of stuck bullets. And it's something you see quite a lot in Turrican. It's something that's always irked me. So I prefer to use this method of keeping a copy of the map somewhere else. So we're going to use that method. So let's just have a look where we've got free. We don't want to use anything in the Vic Bank area, so we won't do that. We only need four pages, so I'm going to suggest we... Where is our Vic Bank? Our Vic Bank is from C000 onwards, so we'll stick it at BC00, because then it's kind of at the end, just before the Vic Bank. So I'm going to, in the map loader, I'm going to create a buffer. And this is going to be like that. Just so we can grab that value again all the time. And then we're going to create a buffer map here. And all this is going to do is just going to take the data from our screen. It's not going to do any of this kind of weird lookup that we're doing to draw the map. The map's already been drawn. We don't need to know anything about the color RAM. We're not going to change anything in the color RAM. We're just going to record what's in the screen RAM. And we'll just do a very naive implementation. We won't even bother stopping at the end of the map. We'll just do the entire 1000 bytes. It's easiest just to do it like that, because it's just simple. I mean, we can stop at the end, but there isn't really much point. So we're going to load screen RAM, X, and we're going to store it at buffer, X. And it's that simple. And we do the same again 3 more times, but each time we're going to add 250. And then we get the 1000 bytes that make up the screen duplicated into another area. The speed of this doesn't matter because it's only going to be done when the map's drawn. It's not something that's going to be done every frame. So it really doesn't matter how long it takes to do this. It shouldn't take too long anyway. We're only loading and copying vars. It doesn't matter if it takes more than a frame, but it's probably not going to take more than a frame anyway. Cool. So that gives us a buffer. So what we can now do is, if in our draw sprites, we can do this two ways. We can either only do it when we move a sprite, in which case we draw, but before we move it, we blank out the sprite and then we change the data so that it gets redrawn here. Or we can just do it in here as well. Doing it in here means every sprite before it's drawn will be cleared and then redrawn. Doing it here, actually, I think it probably does need to be in here. I think we need to clear all the sprites before we draw them. Because, again, if you've got... oh, have I done... Oh, yes. Sorry. Thank you. Go to the head of the class. Yes, definitely. Thank you.
Well spotted there, Furrow.
I think what we've got to avoid is if we've got multiple sprites on the screen moving around in different locations, some static maybe, some moving, but overlapping, that they don't cause left behind character data if something goes wrong. So I think it's going to be slower to do this, but I think it's probably better if before we draw the sprites, we clear the sprites. So we'll have a separate routine. It's pretty much going to do exactly what this routine's doing. So I'm just going to copy this one. And we'll just trim it down to do what we need it to do. So again, it's going to go through each sprite. If it doesn't exist, it's not going to bother. In fact, or should it? No, we'll have, in the remove sprite, we'll have something which clears it. Couldn't we simply store the position of the original map character we replace for each soft sprite? Yeah, I mean, this is essentially what we're doing here. By having that double buffer, it means whenever you... So if you imagine, if we don't have the second buffer, and you've got a sprite on the screen in this location, so say this is our sprite, it's taking up this... why is that not drawing? Is that not drawing onto the map? What's going on there? Not that, is it? Is it? I don't know why that's not drawing. Oh, because it's the character set, that's why. It's not the tile set. So yeah, if you imagine a sprite here, and then I go to draw another sprite in the same location, it needs to know what was originally underneath this one. So if there's two sprites on top of each other, you can't just read what's currently on the screen, you need to know what was originally on the screen. So by having the second buffer, you've got a source of truth for those values, and it's only 1 kilobyte, and it's 1 kilobyte that we're not having to update. Once it's drawn, once the map is drawn, we don't have to do it again. It's always going to be the same. There may be some very rare cases where no, because it's going to be animated chars, color changes. We don't care about color changes. The 1 kilobyte isn't going to be assigned up front, it's going to be generated, so it's not like it's going to count towards the size of the final exe. I think that should be fine, actually. Okay, so let's do the clear sprite routine. So the clear sprite routine needs to do exactly the same thing again. We could probably save these screen X and Y values so we don't have to do them each time. So that's an optimization we can look at shortly. But for now, what I'm going to do is I'm just going to take the routine that we've got and make it work. We can always trim it down at the end. So I'm going to create a vector 2. This needs to be the buffer. So this is map loader. Let's just call it buffer, which I need to grab from the map loader buffer. So this is where we might need another table to grab the buffer. I'm going to put it in. We can, again, these sort of tables like this, we can generate at runtime. So for now, I'm not too fussed about them. But we may want to change this for generated code at a later date. It's not that difficult. Video streaming for itself. Yeah. So this is map loader buffer. Oops. Plus I times 28. Cool. So this would be buffer LSB, buffer MSB, and then in here we do the same thing again. We need to grab the screen row. That's fine. That doesn't change. But then what we need to do is do the same thing again, but with the buffer instead. buffer MSB. Yep. Okay. So we're doing exactly the same routine as we were before. We're dividing those values by 8 to get the actual position on screen. And then instead of loading our data from here, we need to load it from what did we call it? It was just buffer, wasn't it? There you go. Buffer, comma Y. And that now needs to be here, like so. We don't need to do this with the accumulator anymore, so we can get rid of that clear there. We don't need to do that. Cool. And that's now doing exactly the same thing as this, but instead of using the data from our software sprites, it's grabbing the data from the buffer. So, looking at this routine now, what we need to do is we need to clear the sprites before we move them, because if we move them and then try and clear them, it's gonna do the wrong sprite. So before you do anything to change the data in the sprites, you need to clear them. Then you can move your sprite, and then you can draw your sprite. Now when we run this, we shouldn't see anything behind it. It should just... oh no, it's not quite right. So we need to figure out what that extra bit is about there. I'm betting that's the carry flag somewhere. Let's have a look at a clear. Oh, Phoenix. Yeah, this is 6502. Well, technically 6510, but 6502 assembly. And it's a glorious, glorious thing. Although it does only have 3 registers, unlike x86, which has far too many. It also can't do division properly or multiplication without a lot of effort. That just makes it more challenging. It's closer to 8086, 8088 or whatever it is, but I mean it's still more simple than that. It's still very old, but it's from that era. Okay, clear sprite. Where's that clear sprite gone? So we were moving. I think it's probably this. I'm just gonna clear the carry bit there. I think it's just because it's adding one too many, so it's not working. Yeah, there we go. So now we've got software sprite moving across the screen, filling in the gaps behind it, and it wouldn't matter if we have multiple of these because it's always using the buffer behind it, so that's not a problem. So the next step is to actually, what's that there? We've got some weird... what's that about? Is that me just breaking the character set? Let me have a look. Let me just turn off the software sprite routine. I just want to make sure that I've not broken anything, because there seems to be something weird here. I'm not sure what it is. Thank you for the follow, Phoenix. Yeah, character set changes. Why is the character set changing? Let's have a look. So where is our character set? Our character set is at F00. Shouldn't be changing anything there though. Let's turn it on again. Let's just see, just make sure I'm not going mad. Well, it could be when it comes off down here. I think it's because it's going off screen. Because it's going off screen, it's changing some data in a weird place. I'm not going to worry about that for now. I think it's probably going to be alright, because we're not. These characters aren't going to go off screen at the moment. They're it is just looping around. I mean, if I look at the values in X and Y, for for this character sprite, they're going to be quite high, especially the X one because it's 16-bit. The Y one is just looping around, but the X is kind of going off the edge here. But because we're dividing it into screen space and just using 8 bits for the screen space, we're probably getting some weird values. But yeah, I think it's probably going to be alright, so let's just leave it as it is for now. So the next job is to actually draw our character sprite in here. So we know what our character sprite looks like. It looks like this ball at the moment. Where is it gone? In here. So we just need to draw that into these spaces. And this is where it gets a little bit tricky. So we need to think about this a little bit. We'll start just by copying this data into the first sprite and just make sure that we're copying it correctly. So we need to create another routine in here. So we're clearing and then we're drawing. We're clearing, we're moving, and we're drawing. So we need we do need an update sprite, and what the update sprite is going to do is it's going to change the data in that character set for that sprite. Okay. Tell you what, I'll be very pleased if I get this done tonight. I'm hoping I will. I'm determined to get this done in one night. Quite a complex routine, as you can see. There's a lot of stuff going on, and we haven't even got to the masking and stuff yet. But it's fine. I've got my wine, I've got my cigarettes, and I've got no work in the morning, so okay. So let's copy this routine again, and let's strip it down to the bits that we need. I'll leave the labels there for now. So what we're going to need to do, we're still going to need to do our little check to see if we skip the value or not. So this whole chunk needs to stay here, because we're only interested in the sprites that are actually active on the screen. Go for the tequila. No. No. If we make a lot of progress, I may end the stream with a couple of shots, but I'm not going to do it early. No way. Makes a mess of me. The code somehow survived, but me, no, not so much. So our update sprite routine is going to redraw the sprite. First, we'll do a very naive approach. At the moment, everything we've done is quite naive. We're still clearing stuff even if it hasn't moved. We're still drawing stuff even if it hasn't moved, and we'll update things even if it hasn't moved as well. So we'll do the same with the update. We'll even if it hasn't moved, we will update it. So this is actually a little bit easier. So we do need our X and Y, but this time it's not X. It's not screen X and Y. It's kind of like an offset X and Y, if you like. Offset X. Yeah, let's call it offset Y here. And so this is, instead of dividing by 8, this time we just want the 8 bits on the end. In fact, is it 8 bits? Yeah, it is 8 bits, isn't it? No, not 8 bits. It's from 0 to 7. So our character can be anywhere within this thing, as long as 1 pixel of this is still within this square, as in here it's entirely in, here there's just 1 pixel in. That's 8 different positions in each direction. So all we need to do is grab, we don't care about the MSB because the highest bit really doesn't matter. We just need the lowest bit. We need to AND it with 7 and store that in our offset X. So now we've got that. Really simple. Same with this sprite data Y. We don't care about shifting it. All we need to do is AND it with 7 and we've got our offset. Actually leave that there for now. You might need that. Cool. So now we know how far through that character our actual sprite is. And so we need to take our character and we need to do a few things to it. First of all, we need to only draw it. If we think about it a row at a time, offset Y is how many rows we miss before we start drawing it. So, for instance, if you imagine our ball here, if its offset is 3 rows down, our offset is 3, so it's here. That means the first 3 rows we do nothing. I need to think about this.
What area in the buffer has no data, so we just created a chart EA.
Yeah, I think it is. I think when it's... What is it doing when it goes behind? Oh, I think what it's doing, actually, let's have a look. So I've run the right thing. Oh, it's gonna do weird things now because I've... Yeah, I think what it's doing is in the bottom half of the screen it's using high-res characters, and the colour there is not the char colour. It's like a background colour, so you're getting actually getting a stripe instead of a solid block. You're getting stripes. I think that's what it is.
Okay, so let's get rid of this block of code in here. We don't need this.
So we need to get the sprite. We need to get the original data, and we need to start drawing it. We'll do the vertical shift first. So we need to get the original sprite data. So we're probably going to use these vectors for that. So we need to work out what these vectors are. So I think we need to add something else in here. So as well as the char start, we need a label here, which is going to be sprite font data start, and that's going to be position of our sprite font times 8, because there's 8 bytes in each one, plus the location of our char set, which I think is just labeled char set. So I'm just going to check that. It's labeled. It's not labeled, so let's give it a label. So it's, make that a bit bigger so you can see. So this is where the data for this sprite starts. This character starts. So we need to read the data from here and start printing it into the font in here, but at the row that we want, the row kind of moving down. So we'll do it one character at a time. We'll start by doing the vertical stuff, and then we'll adjust the code so that it also shifts stuff across as well. But it's going to start getting a bit tricky, this code, so I need to think about this a little bit. In fact, I'm going to go for a cigarette while I have a think about this, and then when I come back we will symbols to just char start, we will delete that. Why is that a syntax error? It's not a syntax error. Let me run that. Oh, that's fine. Yeah, so when we come back we'll start printing that character into the correct locations. It is going to get a little bit more complicated, so I do need to think about this a little bit. So right, be right back in about 5 minutes, guys. Okay, I'm back. Okay, let me answer Jacob's question, because I think he missed the answer originally. So if you have 2 sprites, you place a sprite on screen there, like that. Imagine this is a sprite, and then you place another sprite on top of it. The sprite that you place on top no longer knows what's underneath. It only sees the original sprite. So by having a double buffer, you ensure that when you clear that sprite, it knows exactly what to clear it to. It reduces the problem of kind of sprites leaving behind incorrect data. You'll only ever leave behind proper map data. And it just makes the system a lot easier as well. Okay, so I had a little thought. I think I need to adjust the way this data is stored. So if I look, oh, okay, pause is just going to crash it. Fair enough. If I just stop the movement in our start routine, where's the move? Sprite, move sprite. Okay, so we stop the moving. Yeah, no problem, Jacob. So I think by doing it this way, when we try, I want to draw the sprite vertically first. So the reason I want to draw the sprite vertically first is we can draw it in its position vertically, and then we can shift it across into the other bytes. But because this is the third byte in the list, it makes adding the sprite, moving the sprite vertically a little bit trickier. So the way I'm going to do it instead is I'm going to arrange this so it goes 1, 2, 3, 4 instead. It should make it a little bit simpler. So let's start by doing that. I'll leave that off for now. So in our draw, it's just a little shift in the draw sprite routine. So instead of drawing, see, we're adding 1, so we'll add 2. I'm going to clear the carry bit there, add 2, set the carry bit, subtract 1, and then clear the carry bit and add 2. And that should produce the same thing, but 1, 2, 3, 4 instead. No colour yet, but we'll probably need it later, or there will be a colour trail. No, so what I've asked for I to do is switch the map data around a little bit, so that the multicolours here. So if we only ever use multicolours and transparent for our sprite like this, then it won't matter. It can go anywhere on the screen, and there would never be any colour clash. We need to try and avoid using char colour for our character. If we use char colour anywhere in here, like that, then it's going to pick up whatever colour is underneath. And I want to avoid having to change the colour RAM. If you change the colour RAM and you've got a sprite like this, which is 8x8, and it's in the middle, you're going to have a big rectangle around it. And that rectangle is going to be this colour, the colour that we set for this. So that's going to make a weird colour clash as it moves over things. And I want to avoid that. So we're going to avoid changing colour RAM in this routine at all. So all our projectiles are going to be built up out of these 3 colours. So we'll just have different shapes and different, slightly different colours, patterns or whatever to distinguish the things, rather than try and give them unique colours. That will cause problems later on. It's alright to use a little bit. So say you wanted to that one. Say you wanted to add a highlight in the corner here. I think it would be fine to do that. That's not too bad, because even if that does move over something that's got a different colour, it's only 1 pixel that's going to change. It's not going to take away from the style of this. You wouldn't have to, you still wouldn't change the char colour, it's just that this highlight might change colour, so it might go purple and yellow as it moves over these locations. I think I showed on my last stream, in Parasol Stars I use a software sprite routine for the elements, and as they move over certain areas of the background, there's a little highlight in the corner that does change colour depending on what it's over. But it doesn't take away from the effect at all, and it's a kind of colour clash I really don't mind, because it's not that horrible colour clash where the background behind the sprite changes. It's just a small pixel within our sprite that's actually changing. But we can look at that later, it's not a problem. So I want to just make sure that this is drawing correctly now. Hopefully it should be 1, 2, 3, 4 and not vertically instead of horizontally. And it's slightly off because I need to pull it by, so hang on, 1 needs to add, okay, 20. So it's this one that's wrong. This needs to subtract 1. That needs to, I think, wait a minute, let's think about this. We're drawing the second one here. Oh, it's because I need to clear the carry bit there, that's why. Oops. I really hate that you can't launch Vice again if it's already open through the Kickassembler. So there we go, 1, 2, 3, 4. So it's exactly the same as before, but now our sprites are kind of drawn in this pattern, which means so we'll start by just using the first column, the 1 and the 2. We'll draw our software sprite in that column, but at the right vertical position. And that will be really easy because we can just cycle through all 16 bytes in this block here. They're consecutive in the character map. So they're these two here. It's 16 consecutive bytes. We skip the first number of rows according to the Y offset, and then we draw 8 rows of this into here. I'm going to leave that highlight in there, actually. I quite like that. I'm going to export that character set now. In fact, I'm going to save this and commit to GitHub as well. So so you guys get exactly what I've got as well. You're following on the flu bits. Did I do the right thing there? File, export, character set attributes, calls. There we go. Save the map. Yeah. I'll just do a quick commit of that. Updated char map. Stage all that. Commit. Push. Cool. You guys should have that now, or any second. Okay, so to go back to what we were doing, I'm going to keep the move off for now, just so we can see our sprite. We do have a little offset, I think, when we set it up. No, we didn't. So I'm gonna set an offset of 5 in the Y and 5 in the X as well, just so we can see our thing. So you'll see when I run this now, it will still be at 0, 0 because we're not doing any shifting yet. But what we're going to try and do now is make it shift. Well, in fact, it's not even showing our characters, but it's just showing these original things here. So let's go into our routine. Where's our update? Here we go. Yep, so we've got our offset Y, X and Y. What we also need here now is this is character start. We need a character data start here. Which is going to be this is also going to be a least significant byte and most significant byte, and it's going to start with this value, and there's going to be 32 bytes in each thing, so it's 32 times our index, which comes from this, and we need to take the low bit of that. So we could have done this with a sprite multiplexer, but there's a few reasons I didn't want to do a sprite multiplexer. One, I think it's an unnecessary complication, and I realise that this is quite complicated as well, but this is going to give us an advantage over a sprite multiplexer. With a sprite multiplexer, you're still going to be limited to 8 sprites in a horizontal strip on the screen on any one line. So if you imagine 2 players facing each other, shooting projectiles at each other, say you fire 2 projectiles each, that's now 6 sprites, 2 players, 4 projectiles, which means you can only have 2 enemies between you. So if a third enemy comes between you, things are going to start flickering. Whereas this method, you can still have 6 enemies between 2 players and as many projectiles, 4 projectiles each in fact. So you can technically have 16 sprites in that row. Can't imagine it. Yeah, and the thing is, I've used to do it like that until I figured out that there was a fill command. I used to do it manually. I used to work it out in the calculator and then slowly add the values one at a time. And again, you'll see this is why I always do these tables. With a least significant byte and a most significant byte, rather than because you could also do could you do it like this? Well, you could use the word anyway. I think you'd have to create a pattern for it, but you could, you know, you could add the values consecutively. Least significant byte, most significant byte, least significant byte, most significant byte. But then it makes it really hard to look them up, because then you've got to start doubling indexes for this thing and not for this thing, and yeah, it just gets confusing. So it's easier just to do it this way. So this table is pointing to the actual font data. So it's pointing to this data here. So we need to start changing that data in our update. So the first 16 bytes of that is going to be our characters 1 and 2. So the first column. Let's get some more cool air on me. It's getting really warm in here. Okay, so we need to grab that data now. So we need this. And we're not using buffer, so we're not using screen rest, so get rid of these for now. I'm going to call this char data. There we go. And that gives us a location for our data, so we can now store a value at. And if we cycle through, so like so, compare y to 16. There's lots of optimization we could do here. I mean, I could reverse this loop as well. I'm not too fussed about optimization now, but it's something we can probably do at a later date. If anybody actually wants to go through the code afterwards, if anybody sees some optimizations that we can do, feel free to look at the GitHub and make a pull request as well. I'll put a link to the GitHub. Feel free to make a pull request, and we can look over it and talk about what's been done on the next stream. I'm not going to go too much into the optimization on stream. This isn't a game that particularly needs that much optimization. So low high fill, yeah, the low high fill is something I think it was only just introduced, was it? One of the last released versions, last 1 or 2 releases. But I think it does exactly that. I think it creates 2 tables, one with low and one with high. I should probably look at that at some point. But for now, I'm happy doing it the way I'm doing it. So all this is doing at the moment is... let's put 0 in there. Actually, is it 0? Because... Well, let's put 0 in, because this is going to actually end up being changed as we start blending stuff in. But for now, let's just clear the data in that location. So let's give that a quick try just to make sure that's actually doing something. So let's think about where we need to update the sprite. So we clear the sprite, we move the sprite, then I guess we need to update the sprites with the new data. We can move this all into a single update function at some point. I'm sure you can point to a few more obscure ones if you want. Well, I really take time to read the documentation. It's a lot more fun. Yeah, I think this is... I learn best when I'm building something. If I was just to sit down and read the Kickassembler documentation, I wouldn't take any of it in. But I find if I've said this before, if you want to make a game, then don't do something you know how to do. Do something that's 99% or 90% stuff you know how to do, but always pick like 10% of things you're unsure how to do, and then you will go and look at how to do them, find, read through the Kickassembler manual. You'll find some tricks that help you do it. You'll look at forums, you'll speak to people and learn how to do new routines, and it'll stick in your head a lot more if you do it that way. You just keep doing the stuff you know how to do, then you're never going to learn, you're never going to grow. I think that goes for everything in code. Whenever you're coding, if you want to learn a new language, don't do something simple in it. Do the little tutorials you see online, spend an hour just getting to grips with the syntax, and then once you've got the very, very basics down, challenge yourself, do something that's a little bit out of your comfort zone, and that way you'll always learn a little bit more, and it will stick in your head way better than just reading and just kind of parroting tutorials over and over again. Okay, so this should hopefully now clear a column, the first column in the sprite. Oh, I don't know what that's doing. Let's have a look. What are we doing wrong? Take sprite. So we get to this point. We've got the char data. And probably need to check that char data to make sure it's correct, because this looks like it might be picking up the wrong value somewhere. I'm going to put a breakpoint in here and just see what it's actually doing. I have a funny feeling that char data is incorrect. So char data is vector 1, which is at 0A. So I'm just going to bring up the monitor. Oops. Oh, the monitor's already been brought up. And I'm just going to check what's in 0A. F5D8. That seems like it should be correct. Oh, it's because of this. That's why. I need to... This is the danger of using these multi-labels and not giving them names. I fall into this trap all the time. Oops. Still not... Hang on. Get rid of the break again. So if it's not doing anything, it skips and goes to here. We're not bashing the X anywhere. X is completely fine. Only ever loading using it as an index. And this is looping back to here. No, that should be alright. Let's give it another try. Maybe it's... Ah, there we go. That's fine. So you can see it's cleared these values with 0. 0 is our background transparent color, which is fine. That's kind of what we want, really. We want it to be transparent until we start blending it in. Did I leave the debug borders on in Vice on purpose? No, I've just left them on. In fact, I'm going to turn them off because we get more screen space, don't we? So for anybody that doesn't know, Vice has a setting that allows you to see the entire border. And so I was explaining on the last stream how there's 63 cycles in each line, and that each screen row is actually 40 cycles, each line, single pixel line across the screen, and that the other 23 cycles are basically here and here. And I was showing how you could kind of see how much space you've got on this side. And you do that by going into Vic2 settings in Vice and changing the border settings. Normal borders is what you would see on a normal machine when you boot it up. Full borders lets you see, I think it lets you see kind of like overscan areas. So on some monitors you'll have an overscan that lets you see way more, and that kind of looks a bit like that. I think you get bigger borders slightly, and then there's debug borders, which lets you see this extra bit down this side as well, just so you know where the raster thing actually is. It's over here. There's more on the left side of the screen than there is on the right. I'm going to put it on normal borders. Normal borders is this is kind of what you would see on a normal machine. If you're doing stuff in the side borders and you're doing stuff in the bottom and top borders, this is the mode you should be looking at, so you know exactly what it will look like on a real machine. I'm assuming most people aren't going to do things in the side borders. It's a bit of a pain to open the side borders because you have to do it on every line. It's not a practical thing to do in games. I've thought about ways of doing it, and it's really not practical at all. you'd have to have something on every single line of the screen. So you'd have to do 200 different settings for the 3840 column mode in order to get these borders open. 200 times, one for each line, with perfect stable timing. Which is not going to leave you a lot of time to do other stuff, so it's not very practical. Top and bottom borders are fine. You can do that once. Do that once down here somewhere. Then it opens them both. I think I've shown that on. I think we looked at it in one of the streams. I can't remember when. I'm pretty sure we looked at it one time. It looks like one of them cool .cosmos effects. Which I don't know which bit you're talking about now. Oh, you mean the screen kind of flicking between the LSD mode? Yeah, I guess it does. Yeah. I'm going overboard with the effects in .cosmos too. I know I am, but it's fine. I'm enjoying it. I'm not under any pressure. There's no deadlines for anything. It's just when it's done, it's done. So. I'm enjoying putting all the extra stuff in. I can fit it in, so why not? The game's going to be awesome. Well, I think it's going to be awesome. Hope you guys like it. Okay, so we're clearing that data here. So I'm going to put a little note in here because it's starting to get a little bit complicated. So I'm just going to put a little thing in which says draw the char data in the left column. And so at the moment this is just clearing the data. What we need to do is once y is more than this offset value, we need to start grabbing the data from somewhere else. Which also means we're going to have to bash the x value. So the first thing I'm going to do is I'm going to store the x value. I am going to create another temp here. I am just going to call it temp. Even though it points to temp, it's just easier if I don't have to remember a number on the end of it as well. And then this way I can start using the x. So this is going to start at 0, but it's only going to increment if y is more than this value. Yeah, it is. I think if people rush games out, then they don't spend the time to polish them. And I think if you don't polish the game, you don't notice the little things that make games fun. And I think that's what all game developers should be doing. This isn't the old days where you've got 12 hours a day every day for 3 months to make a game. You've got a couple of hours after work, maybe an hour at lunchtime, a little bit of time at the weekend. You're not doing it as your main job, so you can't spend the sort of amount of time that people used to make polished games back in the day. A polished game nowadays takes a year, takes 9 months, a year, 18 months. It can take a long time. And I think people need to realise that and stop rushing games out. Just get a game done how you want it to be. You're never going to get rich from the game. So pumping out 10 games in a year isn't going to suddenly make you super rich. If anything, it's going to reduce the number of sales you get. So yeah, just make the game that you love. That's why you do it. That's why people still code for the 64. They code not for the money, but because they love the machine. So make a game you would have loved to have played back in the day. Okay, so we're going to store 0 in here unless this value here is more than or equal to this. So we need to compare y to offset y. We'll start by loading accumulated with 0, so we'll use 0 if this thing fails. If the carry flag is clear, then we're going to skip ahead. There's no data. We'll call it no data yet. If the carry is clear, that means that this value, the y value is less than this. If it's not, then what we need to do is we need to grab the value from in our sprite font data start. From our... Hang on, where would it be? We actually don't have a location for this, or do we? Is that it? Sprite font data? No. No. Ah, we need this ID here. Okay, so at the moment we're just passing in an ID which is 180. We need to convert that. So when we add the sprite, we need to convert that into a sprite data lookup, we'll call it. We can initialize this with zeros because this has to be added at the end. So we'll do that when we add the sprite. Because the sprite data is never going to change, right? The sprite data is always going to be this thing here. But if we have more than one, then obviously we need to pre-calculate it based on what it is. So they can start as zeros, but when we add them, so when we do this, we're going to also add our values. So actually we return the accumulator here. So I'm going to store that in temp1, and then I'm going to load it before I return. So this is going to ensure that we retain the return accumulator that we have here. But now we're going to take our value from here, this one, at this point here. Yep. I mean, we could do it here as well, actually, because we've already got it here, so we might as well do it up here before we do anything else. So we'll do it there. I'm going to put a comment in to say what we're actually doing. Hi, Harry Longbone, welcome to the stream. Yeah, wine for me. I don't have a lot of wine tonight, I'm being good, but if I do run out of wine, I may grab the tequila towards the end. But it's only going to be a little bit, it's not going to be as insane as last time. I'm trying to take my time with it, I'm trying to make this last. But I may have one or two at the end. Okay, so we've got our sprite ID. So to get our font data, we need to take the char set location, which is this, and we need to add our kind of character number, so the value in the accumulator here. So let's just put accumulator. We need to take that, but multiply by 8. So the way we're going to do this is we're going to store the values we need. We're going to start by storing. We're going to store char set in the lookup value. So we're going to take the lower byte of char set, and we're going to store that at sprite data lookup lsb x. That's always going to be 0. I mean, we could just put 0 in here, but it really doesn't matter. This is essentially going to be the same as doing that anyway, so may as well, just to make it clear, do it like this. And then we're going to take the upper byte and we're going to store that in the MSB. In fact, what we can do is not bother loading this and just store this in there instead. You'll see why. So with that value now, if we want to multiply this by 8, but every time we shift it to the left to double it, we need to make sure that this value is also shifted. Actually, is that right? No, this should start as 0 as well. Okay. We need to shift this at the same time. So what we're going to do, we're going to shift that to the left, and then we're going to roll this one. And what the roll is doing is making sure that if this one overflows, that it gets carried into here. We're going to do that 3 times. Like that. So that's now multiplying this value by 8. So now our lookup is going to contain the character times 8, and so all we need to do to finish this is clear the carry bit. What is in the accumulator at the moment? Okay, we need to load the accumulator with the upper bit of the char set, and we need to add it to this. Then store it there as well. There we go. So it seems like a lot, but we're only doing it when we add sprite. But now this lookup now has the location of this sprite. Now, we could have just put it in directly, but if we're going to have multiple sprites, and we've got room here for 7 different sprites. In fact, we've got room for more. We can use any of these. It really doesn't matter. But we've put one here, and we'll say that we've got 7 for now, leaving all this to do what we want with. Oops. Saved. Yeah, why not? Yeah, so that doesn't change anything in X. It doesn't change anything. Oh wait, should this be X or should this be Y? Hang on, store Y. Should be Y, shouldn't it? Not X. Ooh, that would have ended up being a weird bug. Oh, really, Sublime? Really, you have to give me that window every time. Okay, cool. And now, in our update down here, where was it? Update. When we have got data, we can then grab it from that list. So we can go load. Actually, we need to store it first. So we need another one of these, another vector. We'll call this sprite data. Lookup, sprite lookup, I guess, to match the other one. I can't drink coffee without sugar. You know, I drank coffee with sugar for 25 years or so, and last year I went through. I had a bit of a crash. Probably heard of it, ketogenic diet. And sugar is a big no-no. So I went for three months or so without sugar, and now I can't drink coffee with sugar at all. But weirdly, I can drink coffee with a spoonful of butter in it. So, you know, I don't drink it anymore with a spoonful of butter in it, but it's actually quite nice. I used to use butter instead of milk during that period. But yeah, I don't drink it with sugar at all now. It just tastes weird without. Yeah, seriously, try it. Get a teaspoon of butter, mix it into your coffee, and it's delicious instead of milk. It's very nice. Yeah, because the ketogenic diet means you cut out carbs completely and you increase your fat intake. So one way of increasing your fat intake is replacing sugar and milk in your coffee with butter. It adds a kind of it's a strange taste, but it's nice. It takes a little bit of getting used to, but it is very nice. Okay, where was I? Sprite lookup. Okay, yeah, so we need to set the sprite lookup before we go into this routine. So, yep, so we're going to load sprite. Sprite data lookup. It's comma X, I think. Yeah, X. Store that at sprite lookup. So the problem I see here is that actually we can only do this using the Y register, and we're already using it here. So either we have to transfer the Y register around a lot, or we have to think of a different way. So I think what I'm going to do instead is I'm going to use self-modifying code here. So what we're trying to do basically is we're trying to load a value indexed from a area in memory, indexed with X, because we're no longer at that offset. And then we're going to increase X, and we're going to over. So yeah, that's fine. We'd also here we do need to compare X with 8, and if it's more than 8, then we also need to do no data yet. Because once you've drawn 8 lines, you don't need to draw anymore. So as well as checking if we're beyond the offset, we also need to check if we're if our x is more than 8. So this is going to be self-mod. So I'm going to call it self-mod lookup. And instead of doing that, I'm just going to do that instead. And that should be enough. Shouldn't need to change it. Yeah, but butter is nice. Butter is strangely nice. It's not something I would have expected to be nice, but it is actually quite nice. I think they call it bullet coffee. I think that's kind of like the American term for it. I think you can go into some coffee shops and order bullet coffee. I gotta say though, the ketogenic diet was brilliant. So I'd get up in the morning and I'd have a coffee with butter in it. I'd have a pile of bacon and eggs. For lunch I'd have steak. Everything was just shitloads of meat. And as the fattier the meat, the better. So like really fatty bacon, like covered in grease, was just perfect. And I lost a lot of weight. I lost probably about 15 kilos in 3 months, just by eating sausages and bacon and eggs and putting butter in my coffee. Yeah, it's a very impressive way to lose weight. Kind of like Atkins diet on steroids. Okay, so this is a self-mod, so this is being looked up from here. So hopefully now this should draw our character within that vertical block that we had. Char set is... Oh, that's because we're running from the wrong side. Okay, so invalid address mode, can't shift absolute Y. Ah, right, okay. I need to look this up. Might need to do some adjustments here. So, shifting. Let's have a look. Where is it? Shifting has absolute. Yeah, so it's only got an absolute X mode. So I need to change that to be X instead of Y. Okay. Yeah. Good night, Amok. Thank you for joining the stream. I do like the Monty Python reference there, Akmafin, very good. Spam, spam, sausage, eggs, and spam. I don't like spam. Is there anything without spam? Well, the spam, 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 egg and spam doesn't have much spam in it. Yeah, awesome. Okay, so we need to use X instead of Y here. Ugh, okay, fine. So I just need to shift this all around to do X instead of Y. So okay, so that's right. I need to think about this. Okay, so we're going to store X instead, and we're going to use X throughout here. But that now means X is in temp and Y is not. So whenever we reference those later on down here, we need to change it. So it's fine to use X down this slot because this is where we need to use it. Oh god, Kickassembler is so annoying. Well, it's not even Kick, this is Sublime doing this. So this is actually wrong. This is the other way around, so that should be that, and that should be transfer Y to the accumulator. And that needs to store X to temp1. That needs to increase X. Okay. I don't know how confident I am about that. We shall see. No, something's gone horribly wrong there. Okay, I am going to turn off a few things at a time. I'm going to turn off the update sprites just to make sure that the original add sprite code hasn't broken anything, which it hasn't. This is fine, which means the code I've just changed has worked. So it means that something in the update sprites is wrong. So let's have a look at what we did in the update sprites. So there's this self mod area here. Let's just turn off this self mod stuff. This was the original code. This should now just do the black strip down the first column. Yep, so that's correct. So it seemed to be something to do with this stuff. So let's try, instead of the self mod, let's just try put in FF in that location. So we're going to do the same check as we did before, but we're not using self mod. So now we should have a block of eight rows that is not black. It should be whatever it is, whatever the char color is in that location. So it's something to do with that that's wrong. Okay. Right, first of all, it shouldn't be FF, it should be that. We are storing at char data, so that should be correct. The Y register doesn't appear to be... But, oh no, that's fine. This should be comparing to that. That should be fine. That should be fine. Okay. The branches back. Oh, it's because when we're finished, we need to grab that value. Because we bashed X, we needed to store it first. So we stored it here, and we restore it here. There we go. And so you can see now we've got a block of lines there that are 5 characters down. So we've actually created something 5 characters down, which is because of this. And so we can restore that now with b, comma, what would it be, comma X, because we're looking up based on that, and we can restore this piece here. Cool, so now we've got our character moved vertically correctly. Now we just need to move it this way correctly. So the way we're going to do this, once we've drawn once we've drawn this bit here, so once we've drawn the character in the column, the next step is to shift that data across into the other ones by the number of shifts that is here. So the first one we'll do is we'll see, actually, do we need to, yeah, so we need to go through each row again. So we're going to do the same thing again. We'll leave X as it is there, so we can use it. So I'm going to put that up here. So that's iterator, not increment, or is it iterator? So we can do this in the same loop, or we can do another loop. I'm going to do it as another loop just to make things a little bit simpler, a little bit easier to read. So now we've drawn it, now we're going to shift character horizontally. I'm sure this could be way more efficient. In fact, and what I'm going to do in here, clear sprite, update sprite, yeah. But in here, I'm just going to put that so we can see how much space it's taken up. If we run that now, we should be able to see. Actually, we can't see. This is another reason full borders is really useful. If you're using borders to see what's going on, you can see. So there you go. It's taken up quite a lot. But you consider what we're trying to do. This isn't that bad. And I think even when we've got 8 sprites, it's still only going to be, you know, maybe to here or so. And there isn't an awful lot of other things going on the screen, so it's fine. And in fact, we can stagger the updates as well. So we don't have to update everything in one go. We can update half of them on one frame, half of them on another frame, which is another trick that we do quite a lot when we do these sort of things. So this is fine. I'm not too worried about that. I'm sure we can optimize this further. But for now, this is absolutely fine. We'll just keep an eye on it as we go. Okay, so we need to shift the character horizontally. So we're going to do the same loop again. We're going to start at 0, and we're going to keep going until 16, and we're going to loop like that. But this time what we're going to do is we're going to... should I... I'm going to create another vector here. Just going to call it right. It's the right hand side. I should probably call that char data left actually, then it makes sense. Let's go and change where that's being used. So, and then char data right is basically going to be the same thing plus 16. So I'm going to do the same thing again. This time we're going to add 16. Is it 16? Yeah, 2 characters, 8 bytes each, 16. Yeah, and then add 0 on this one to get the carry bit, and that goes in the right hand side. So one optimization we could do is we could pre-calculate these values, you know, the start of the left and right sides, because they're already in the data here. We could pre-calculate this so we don't have to do these adds here. We could also store these in 0 page instead, which means we wouldn't actually even have to do any of that chunk of stuff there, wherever it was. Where's it gone? Oh god, I can't find it now. Yeah, we wouldn't have to do any of this because it would already be in 0 page. So that's an optimization we could do. What I might do after the stream, I may go through and optimize it a little bit myself. But I'm not too worried at the moment. I don't think there's going to be many cases where that 8 projectiles on screen, and even if there are, I don't think 8's gonna cause us that many problems. Oops, what did I do then? Oh god, I'm pressing all the wrong things now. What have I done? Whatever, it's fine. I open Streamlabs, that's fair enough. Okay, cool. So we need to shift the data horizontally. So now we need to grab, well, first of all, we need to clear the data on the right hand side. Ooh, I bet we can't do indirect indexed with shifts. Let me have a look. Yes, there is no indirect with the shift, so we may need to use self-mod here as well. We think, oh, we can store it in temporary values actually. So we've already got a temporary value. So I'm going to store that one in temp. No, can't use that because it's been used there. Okay, I'm going to create another one called shift temp. I'm just going to use temp 4. Trying to read what he's saying there. But it's something like this, you could use I could use multi-cursor. That's a very good point actually. They see, that's something I see a lot of people using that, and occasionally I've used it, but I just never think to kind of do it, and it would have been a lot easier to do that. I mean, look, there you go. It's just something that never occurs to me while I'm doing it. I think because I don't use it all the time, I never think about it like that. It's a shame, really. Because yeah, that would have been a lot quicker. Was it? Did I shift underscore temp? Yeah, I did. All right. So we're going to store the right hand side into a temporary variable. Then we're going to load the left hand side. And now what we need to do is we need to set a counter up. And that counter is offset X. So we're going to load X with offset X. And we'll call that in a loop. I'm really not liking these label names. And we'll call this one end loop. And so what we need to do is, if X is 0, then we jump to end loop. Otherwise, we shift or roll. No, we shift. So otherwise we shift to the right the data in the accumulator, which will put anything in the last bit into the carry flag. So then we roll the value in shift temp, which will grab the value and stick it in bit 7. I'm just trying to think, and then decrease X, and I kind of, I don't want to use a jump here. I don't like this branch being here. Actually, what I'm going to do instead, I'm going to make it skip over it immediately if it's a 0. And then branch not equal, there you go. So what this is doing is, for every value that the offset, so if the X offset is 3, then we need to shift it over 3 times. So it's taking the left hand side, shifting it to the right, with bit 0 going into the carry flag, and then it's taking the right hand side and rolling it to the right, which means it's taking the value of the carry flag and putting it in bit 7. So it's basically a 16-bit shift, but it's going to shift our character across into the other 2 values. And then what I need to do at the end of that loop is I need to, whatever's in the accumulator is what should be going back into char data left. So I'm going to store the accumulator in char data left, and then whatever is in shift temp needs to go on the right. So I'll tell you what, I'm going to have a lot of fun writing this up, aren't I? Trying to explain this in a PDF is going to be a hell of a lot of fun. So this might be the longest one yet. It's all good, I enjoyed doing it, it's fine. So I think now that should shift our character. So we should see a black square with this thing 5 pixels down and 5 pixels across, if everything's gone right. And something's gone wrong. I think I've done a... Oh, okay. Have I done something weird there? Well, we'll soon find out. If it complains about missing labels, I've done something wrong. Don't think so. It looks like there's the right number of labels there. Cool, and there we have it. Our character has moved into this location. It is the wrong colour though, which is weird. So the reason this is the wrong colour is because we're in multicolour mode. So what's actually happening here is, if we just do vertically, it doesn't matter because you've only got 1 pixel in a multicolour, 1 pixel height in a multicolour pixel. But when you go horizontally, if you move an odd number, you're actually shifting all the multicolour data by 1. So we need to make sure that when we shift these sprites around, that we always increase the X by 2 at a time, not 1, or else the colour will change. So if I change this to 6, the colour should be fine. There we go. And you can see how this highlight is the colour of whatever's behind it. So I'm pretty sure if I go and have a look at oh no, it's white. Oh no, it's red here. So the tile here is made up of 4 characters, and one of them is red. Is this one here, which is why we're seeing a red blob on there, because it's one being used. So cool. So now when I move this around, if I use the same routine to move it around, first of all, what we'll see is, because we're just moving one at a time, we'll see the thing flicker between blue and green, as I say, because it's multicolored, so it needs to move 2 at a time. But I want to show that first, and then I will change this to a 2. But you should see that it moves smoothly now, although with a massive black rectangle around it, which is the next thing we're going to address. You can see it's moving fine, it's moving smoothly. It's flickering between the 2 colours. So if I change that value to 2 in here, and now it's green. And that's not bad. That raster time isn't that bad. I think we can do some optimization, and I think after the stream I will do, because obviously we don't want to take the entire frame up just doing 8 software sprites. So I will do some optimization on that shortly, probably tomorrow, I think, to try and just reduce the cycle time that it's using. We will stagger them out as well, so we can, so for instance, we can always do the draw sprite and the clear sprites, but these can be staggered. So the first time you run these, it will just do the first 4 sprites, and the second time you run it, it will do the other 4 sprites. So it kind of slows down how quickly you can move things, but it does mean that, you know, we're doing half the amount of kind of sprite updates per frame. In fact, I think on Parasol Stars I stagger, I think I've got 16 or 24 software sprites, and I stagger them out. I stagger them out by about, I think it's 2. I think it only updates 2 per frame, or it might be 4 per frame. You can jump up the right hand side wall, can you? I want to see that now. Oh, you mean using the... Oh, yeah, that's the point. Shouldn't be able to do that. Is one of the blocks missing a collision, maybe? Okay, we need to look at that at some point. Not sure what that's about. Can't jump up that one. Let's have a look. They're all material 1, so we probably just need to get the collision routine fixed a little bit, because he definitely shouldn't be doing that. That's fine. We can look over that. It's a bug we need to look at. But yeah, we've got character moving across the screen. So obviously the black rectangle behind it is not good. So that's the next thing we're going to do, and this is where the magic happens. So this is going to be where, in this routine, where we're doing the blending between the 2. So again, so this bit here. So before these values are actually drawn, it's going to take the data that's already on the screen. We can't use the buffer here. We have to use what's already on the screen, because if you draw multiple characters in the same place... Oh, actually, this is a good point. If you draw a character on the screen and you do it all at the same time... Let me think. Is this correct? No, it needs to take what's on the screen already, I think. I think we maybe need to... I think maybe the draw sprites needs to happen immediately after the update sprites. So once a sprite has been... So instead of it being update all the sprites individually, then draw all the sprites individually, update sprites would be a routine which updates a sprite, draws it to the screen, updates a sprite, draws it to the screen. Then that way, if there's multiple sprites on top of each other, when they get the buffer that's behind them, you'll be getting the right thing. So we'll change that routine in a minute. But first, I'm going to go for a quick cigarette, finish this wine. Yeah, I've got another 2 glasses, so I'm doing all right. And then we'll do the blending. In fact, the first thing we'll do is we'll mix the draw and update together so that they do everything in one go, per sprite, rather than as a block of updates and then a block of draws. It will be update, draw, update, draw, update, draw, instead of update, 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 draw, draw, draw. That makes sense. Anyway, right, back in 5 minutes, guys. Right, let's do this. Alright. Fresh wine. Let's have a look. So, first thing I want to do is this draw sprites routine. I want this to happen after each update instead. So I'm gonna move it to near the update so I can actually work on both easily. Clear sprites can stay down there. Stick it in there. And we're going to get rid of the loop from this. So we no longer need to set the X. I'm going to assume the X is set when we go in, and we're not going to do this anymore. So we're just going to deal with one sprite. We need to see what values are being set at this point. So we do it here, because this is restore X iterator. The one in the pic below, I don't know which pic you're on about. But welcome to the stream, Bob the Builder 11. One in the pic, I'm not sure which pic you're on about. Oh, you mean in my... this thing in the background here? This? I mean the computer. Oh, I use a Corsair K65. That's a Logitech 101 or something. G910. But I use a Corsair K65 for my normal dev. It's very loud as well. You can probably hear it. Okay, so let's take a look. I just bash it with my fists. Yeah, it sounds like I'm bashing it with my fists, but I'm not. It's just super loud. Okay, Y is fine to use because it was used in this loop. X is fine to use because we restore it here. Accumulator is fine to use as well, so we can just jump into this routine. We need to make sure that our X value is set, which is actually this here, so we do need to do it after we restore. So we restore the X iterator, and then we can jump to this draw sprites routine. Now, we need to make sure that none of these temporary values are being bashed as well. They're only being used within the loop, they're not being used outside the loop. So I think they're fine to use. I think that should be fine, so let's just run that and make sure that works as well. Oh, do you mean in my... hang on. Oh yes, that's a Commodore 64. That's a bread bin C64. I get what you mean now. Yeah, I didn't quite understand. It's a whole computer, yeah. And the best computer ever as well. If I could use Kickassembler directly on the Commodore 64, I would. But unfortunately I can't. I think that should be fine. I think that should be enough to test it now. So I'm just going to give that a run. I think I did already, but... Oh no, it's doing some weird clear stuff down here. Okay, so let's figure out why that's happening. It's probably going to cause a crash at some point. Okay, so that's going in here. It's screen row, screen row, screen row. Screen row is being set there. X is the index that we should be using, which it is, it's correct. Reload our sprite. Do we already have that data? I think we do. Oh no, we have the offset up here. I wonder if it's to do with this temp value. Something in here is causing a problem when I call it from here. What might that be? Oh, hang on. Are we keeping the X value or are we destroying X? No, we're keeping the X. The X is not changing. Fine. Y value is the only thing that's changing, and the accumulator. I don't think there's any. Yeah, so Y value accumulator. Maybe the carry bit. Do we do anything with the carry bit up here? There is an add here, but we clear the carry bit first. There's no rolls before it. Let's have a look again, see what that's actually doing. So the weird thing is it's drawing our sprite correctly, but then it's also oh, I know why. It's because in here we call draw sprites and we don't need to call that anymore because now it's all being handled by update. So it was fine. The code was fine. I was just doing an extra call that I didn't need to do. Yeah, there we go. That's fine. So now that's moving across the screen correctly. Obviously it's still doing this weird thing down here and it's causing some character set glitches when it goes off screen. But until it goes off screen, everything's fine. So the next job is to read what's behind it and merge that in with it. So the way we do that is pretty simple, really. So let's have a look. So we can grab this data here. So this is where we can actually start merging this code in here anyway. So what I'm going to do, we need the screen row lookup. So I'm going to take these values and I'm going to store them locally. So I'm going to do screen X and screen row. I'm going to move them into the other routine. So let's grab them, stick them up here. Getting quite complicated, this function, but it's fine. So it's vector 4. We're going to need another temp value here. So we're already calculating the offsets here. We need to also do this calculation in here as well. So I'm just going to put it there like that for now. That should be fine. I don't think we're bashing anything that we shouldn't be bashing at this point. X isn't changing. That's fine. So now we've got screen X correct. And screen row is set up as well. Screen Y should probably be saved, so I'm gonna save that as well. Because at the moment it's just being transferred into... Oh no, we don't need that because this is being saved, so we don't need that. That's fine. Although I'm gonna leave that temporary label in there because it may be used at some point. Okay. So this is just drawing, which is fine. We need to put that label back in here as well. Screen X and screen row, because they're going to be used for this. Screen X, need that, and I need that as well. They're just labels, so I can just reuse them. The values are already set by this function. Do I need temp? What is temp up here? I want to make sure I'm not bashing it. That's offset Y, so I'm going to move that to temp 6 down here. This is becoming a little bit messy, so I am definitely going to go through this at some point and optimize it. I'm not that keen with it at the moment. Okay, this jump has become too long now, so we've gone through this before. When you get a branch like this and it's too long, all you need to do is invert the condition, make a later label just ahead of it, change the original jump to an actual jump, and then do that. So you're basically skipping over if the condition is the opposite and then jumping. We've got another one, skip 130 in soft sprites. The same again, we find the condition which is here, we invert it, we point it to a label just ahead, we jump with the original label and we put the new label in. Okay, so everything's still working exactly as it was. There's a bit of a flicker as it goes here, but again I think that's because it moves off screen. I think as long as it stays on screen we're fine. What I might do in a minute is make it bounce around the screen. Once we get it working, we'll just test out that it's not destroying anything by having it bounce around the screen. Probably the easiest way to do this. Okay, so now we've got the screen row and we've got a screen X. We can get the data underneath each of those characters. So this is where it gets a little bit tricky, because what we're doing here is we're just taking the data consecutively in the font set, changing the first row, shifting it into the second row. But now what we need to do is we need to take each individual character one at a time and merge it with the data behind it. So this is, I'm going to do this as a separate function rather than mix it into there. Like I said, I'm going to go through and optimize this at some point. I'm not that keen on the length of time it's taking to do these sprites at the moment. I don't think it's going to cause us a problem, but I feel like this kind of block of raster time can be massively reduced with some clever optimization. So we'll do that at a later date. Let's just get it working first. Get it working first, optimize later. Okay, so we're going to go through each of the characters one at a time, grabbing the data. So let's think how we do this. So the first thing we need to do is grab the current data at the screen row. So we need to grab screen row, comma Y, and we need to do that restore, yeah, to draw it, okay. And we need Y to be offset X. Now we've got the character that's at that location. So what we need to do is we need to convert it. So I'm going to make another function that's going to use vector 5. I'm going to move these. Actually, I'm going to move the IRQ temps up to another area somewhere, so they don't get in the way. So given a character, actually we're already doing this up here. Where is it? No, not with that bit. With where is it? It's getting very confusing there. Not that one. I need to grab the original data. The original data is, what did I call it? It was char lookup, wasn't it? Lookup, yeah. So where's that lookup? Doesn't feel right. That's not right. Where is it? This bit. Hang on, char data start.
There should be an add char set somewhere. Add the upper byte of the char set. That's what I'm missing. But I can't see. Should be here somewhere. Oh, it's because we do it in. We do it here. That's why. Okay. Okay, that's fine. We do need to move this into another function. So I'm gonna make a function called get font lookup. And so, given an accumulator value, it needs to do this basically. Which is, it needs to we'll use temp6. It's getting a bit messy. I don't like this at all. This definitely needs. Do I ever sketch this stuff out on paper? Yeah, I do sometimes, but to be honest, with stuff like this, I will tend to just let it flow and then go back and optimize it later. There are some things I definitely have to write down because they get way too I mean, this is complicated, but it's still working in my head at the moment, so it's fine. I mean, I am kind of on the border where I probably wish I'd have kind of written it down on paper first, but that's not going to work very well on stream, so I'm happy to keep trying to do it like this. And so I need to, what do I need to do? I need to shift to the left. Yeah, shift to the left, roll the value in temp6. And I need to do that 3 times. And I need to store that. That's the lower byte, which goes into vector 5. And then I need to load temp6, add the upper byte of the char set. Yeah, it will. This isn't bad at all. Most of the bytes go on graphics and on music. You'd be surprised how quickly code compresses. If you think what the compression does is it looks for patterns. So it does a run length encode and then it looks for patterns. So with code, there's not a lot of run length encoding you can do, but it will find patterns. So it will see this repeating, and it will create a token for this, and then it will just say token times 3, and that's then 2 bytes instead of 9. So yeah, there's a lot of ways that the compression can help you, and code compresses quite well. SID music, not so much. SID music, I think it compresses a little bit better than most things, because you do have a lot of kind of repetition in music. But graphics is awful. Graphics is the hardest thing to compress. Okay, so row, add the char set, and store that at vector 5 plus 1. So now vector 5, when I call this with a value, will be set to a particular sprite, a particular location in memory. And so what I can do in my routine down here, I've got the value of the character underneath the sprite right now. I'm going to jump to this location. Now vector 5 is the data that's under that sprite, and now I just need to do 8 things. So I need to take, well, let's do something simple. Let's take the value that's at vector 5, which I'm going to give a name it up here so it's something a bit obvious. Original data vector 5. So we'll just do the top left block first, and then we'll work out how to do it on the rest. And this needs to be Y, not so. And that needs to go into, we've already got this here, char data left.
So one optimization we can do is we can get rid of these comparisons by doing the loops backwards. So that's one thing I'll be doing at some point. So what this is going to do is it's not doing any blending right now. It's just going to fill in the top left corner of our software sprite with whatever's behind it. So we should see the top corner missing basically. Okay, it's doing some kind of odd things. So let's slow it down a little bit and see what's going on. So it's not entirely correct. It seems to be grabbing... Where's it gone now? I'm back on screen. There we go. It's clearing the top corner correctly, but it's not filling in the right data. We need it to fill in the right data so we can blend it. It seems to be grabbing some data from somewhere else on the screen. So we need to make sure that this routine is actually grabbing the correct things. So I'm going to stick a little break in here just so I can see what this value actually is. And screen row is vector 4, which is at 1, 0. Let's have a look. So this should be drawing to the top corner. So it's definitely filling in the top corner because we're seeing that gap. So yeah, we just need to make sure that it's grabbing from the right place. So let's start it. Oh, it's going to be really slow now because I've done that. There we go. Okay, so it's saying... Let's disassemble the code around this location. Actually, no, we don't need to do that. Checking 1, 0. C000. So that's saying that our sprite should be grabbing the very top location of the screen, which it is doing. That's correct at that point. But I'm going to advance it slowly as we go. It's going to break every frame. So now it should be grabbing C001, so let me check that it's doing that, which it's not. It's at C00, so something's not right here. Okay, let me advance again. D028, so now it's gone down a line. It's gone down to here instead. So I think the calculation that I'm doing, right, offsets is wrong. No, offset's right. It's this that seems to be wrong. Should be grabbing X and Y correctly, which it is. Well, it should be doing. That's okay. Offset X. Oh, it's not offset X. That's not what I want. It's screen X. That's what I need. Oops. So that should be C00. No, it's C028 still, which is weird. So it's moving correctly through the grid. That's fine. That hasn't changed. C078, so this is saying that this row... Oh, actually, maybe it is correct. Oh, hang on. 1, 2... I can't actually tell how many rows that is. 3, 4... No, that probably is correct. Okay. Let's advance it slowly as it goes over things. That's correct now. Okay. Okay, that looks like it's fine. So I'm going to take that break out again now. Wherever it's gone. Should see. Slow it down. we should see the correct thing in that top left corner. If we see that, then we know we're kind of part way there. There it comes. Oh, maybe I've done it a bit too slow. Yeah, this looks fine. So obviously this is all this is doing at the moment is it's taking whatever we've drawn there and replacing it with whatever should be there. And we don't want to do that. What we want to do, yeah, this is fine. What we want to actually do is take the data that we originally had in this location. I think how's best to do this. Where can I store that value? Right, I need to look at the opcode table to see what I can do with the OR command. So I can do indirect 0 page Y with OR commands. So any of the logical commands add in comparisons. The comparison, add, subtract, and ORs. Okay, and I'm guessing load and store, obviously. Yeah. Okay. So in that case, what we need to do, we need to take the data that's originally there, and we need to add our data to it, and we need to do that. Now this is going to kind of half look right, but not quite, and I'll explain why it's not quite right in a minute. This goes to this extra table we need to make. You can see it's kind of drawing it, but it's still failing because it's not the right color, and it's actually causing color clash when it shouldn't be doing. So what's happening here is, if you imagine the data, let me find a little blank area. So let's do it here. So if you imagine the multicolor data, multicolor is 4 pixels, right? So data looks like this in pairs, depending on what color it is. So say this is the background color, and our ball, one line of our ball looks like this, because this is the background color using 1 0. This is another color, the color of our ball using 1 0. When we OR those two values together, what we actually get is 1 0 1 1 1 1 1 0. So what we're getting is where there is no data in our ball, where it's transparent, the data is correct. But where it's merging the data, what's happening is we're no longer using the ball color, we're no longer using the background color, we're using a different color, we're using the third color instead. And so when we get that kind of clash of two colors, we actually end up with a third color and we get color clash. And so what we need here is a different table that we're going to use. And so I'll explain what the table does. I'm going to put a function down here, and I'm going to call it create mask table, and I'll explain what we need to do. So if you've got a character, that's our background character, this is our ball character. What you're interested in is the pairs. Each one of them is a pixel. So in order to merge these two, what we want to see is this. Because these two pixels should override these pixels should be removed and replaced with these. Right, that should be that. There we go. Should be replaced with these. Now the only way we can do this is by first of all ANDing this value with a value that matches our pairs here. So if a pair is transparent here, it's 1 1. If it's not transparent, it's 0 0 0 0 1 1. Now if we AND these two together, what we get is 1 0 0 0 0 0 1 0. And then if you OR those two together, you get this value here. So the difficulty is in making this table. So the easiest way to do this is if you take any number like this that's got random colors all over it. So now we've got a multicolor byte that's got lots and lots of different colors in it. In fact, it's got three, the character color and the two multicolors. So what you can do is if you take this number and you first of all shift it to the right. So now you get and it with this, you will end up with this value. Then you shift that to the right and you get this value. And then you AND those two together and you get this value. Sorry, all those two together and you get that value. Then you do the same thing, but this time you shift to the left and you AND the original value with this. So get rid of those. So you AND these two together and you end up with 0, 0, 0, 0, 1, 0, 1, 0, 0. Then you shift it to the left and you'll end up with 0, 0, 1, 1, 1, 1, 0, 0. And then if you all those two values together, you get 1, 1, 1, 1, 1, 1, 1, 1. And that's because every byte of that is full. Now, if you did the same thing with this, you've got 3 pixels that are blank and 1 that isn't. And so the end result of doing all of that would be this mask. So it's a little bit convoluted, but what it lets you do is mask just multicolor values. Now, I already looked at this ahead of time, so I am going to cheat a little bit here. I'm going to bring up Discord. I did this through the week. Oh god, where did I put it? That's the question. Code snippets, got to be. Look, yeah, there we go. And I wrote this little routine. So I'm using 0 page, but I'm basically doing the same thing. So this, why can't I click on that? What's going on? Okay, for some reason this, there we go. And I'm going to call this sprite mask data. Sprite mask table. I'm just going to create a blank table here. And again, I'm going to fill it with zeros. It actually doesn't matter where I put this. I could probably put this at the end of memory. In fact, I'm going to stick it up here with the other tables with zeros in. It makes sense. And so what this function is doing is exactly what I just explained. So this value here, actually I'll do it in binary so you can see it, is taking the first mask for all the bits that are on the left of the pair, and this one is taking all the bits that's on the right hand side of the pair, and then it's just using some temporary 0 page values to store them. Is this one it's shifting to the left and then ORing it, this one it's shifting to the right and ORing it, this one's shifting the left to the left and ORing it, and then the whole thing is I've not done exclusive OR yet. So exclusive OR is it flips all the bits in a value. So if this is our pixel that we're trying to mask, the routine that I said will return this. But what we actually want is to get a background, to mask the background so that this pixel is showing. So what we actually want is the opposite of this, and the way you do that is using exclusive OR. So exclusive OR will take two bits, and if they're different, it will create a 1. If they're the same, it will create a 0. So by exclusive ORing with 1, 1, 1, 1, 1, 1 all the way across like that, by doing this, EOR, FF, you're basically saying Any bits that are different, they become 1. Any bits that are the same become 0. So same, same, different, different, same, 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 same. You can see we take the original one and we flip it. And so that's what this is doing here with the E or FF, and then it just stores it in our maths table. So I'm going to leave that code there. I've kind of explained it, maybe not quite as much as I could have done. But I have... It's kind of hard to explain, but I think I've tried to explain it as best I could. If you want to know more about this, when I do my PDF for this stream, which is, to be honest, there's so much in this stream, it's probably going to be split over 2 PDFs. You can sign up for my Patreon, and I'll go into a lot more detail about how this works. That's the link to my Patreon. It costs about I think it costs $2, because I think there's $1 is your kind of patron sub, and then you have to pay $1 to patron to do it. But there's great PDFs there, and this sort of stuff is the sort of things I'll go into more detail about in those. But for now, you can just know that it will take a multicolor pixel and create a mask that allows you to cut a hole out in the background in order that you can paste that pixel on. So we've now got that in the mask table here, and so all we need to do is, when we take our background character, the first thing we need to do before we OR our value over the top of it is, where is it? That's where we are now. So we've got our character here. We will transfer that to... Is the X register safe? Yes, it is. We'll transfer it to the X register. We'll OR that value with the mask table. Sorry, and it with the mask table. And then we'll add our character on the top. And so the only other thing we need to do is call our create mask table. And we'll do that up in the beginning and our entry point here. So let's do it. We'll have a set of routines here. Set up generated tables, we'll call it. Because I think there's going to be a lot that we put into this location to save memory. So cool. So hopefully now when we run this, and this is a big hope because I've not done this yet, so hopefully when we run this, it should give us the proper background masking, and the colours should be correct this time. Make the speed correct. Uh, 20%. Although it's not doing, it seems to be blanking it out completely, so okay, let's do a little test on that. So let's make sure doing the correct thing. Let's have a look at our mask table. So let's just put the mask, let's put a I'm just going to put that in there. This is just going to help me see it in here when I run it, so I know where it lives. Mask tables at OEFA. Okay, so oh god, I never get this button right first time. Alt M, there we go. OEFA. I have looked at this table so many times, so I kind of know if it looks right, and it does look correct to me. So I think the table's correct. So let's have a look, just double check the code to make sure it's doing the correct thing. Let's get rid of that again, don't need that now. The mask looks correct, so I'm not sure what it's doing wrong. Yeah, I was doing a lot of testing of the table at work. I wasn't doing any code as such, but I was kind of testing values using JavaScript. So I was making the table in JavaScript first and then testing it against what my code was producing using Easy6502. That site's brilliant. I didn't even have to load the Sublime to do it. So this is loading the value that's actually in our
font lookup. I need to change that. I've called it vector 5, but I have actually created a original data for it. So let's put that in so it's obvious what we're doing. Transfer that to the X register so then I can and that data. Math table should be correct. Because this would imply this is 0. This would imply that the table is 0, and that's not. Because if I do and 0, we'll get the same effect. Blanking out the background completely. Whereas if I put something different in there, so if I put let's just blank out the middle 2 sections. So we'd need C3, I think would do that. And this will blank out the middle. Oh no, see that's doing something odd. Let's have a look. To be honest, I'm surprised there hasn't been more go wrong with this. It's gone relatively smoothly so far. Oh, maybe it isn't. Maybe it shouldn't be inverted. Hang on, and the background. I want to blank out the background where the pixels should be. So yeah, that should be fine. C3 should be blanking out 2 sides. Oh no, that is correct. But this is wrong. This value is for some reason wrong. I'm gonna put the label back up there so I can figure out where it is. Yeah, that's exactly C3. So that would keep the background in those 2 locations. So let's do that again and just pause it so I can show you. So if we look at that top section, pause. There we go. You can see it is leaving where the mask is 1. It's leaving the background in those locations. So that's correct. If I was to change that to FF, it would just completely leave all the background. We'd end up in the same situation we were before, where it would be flickering against the background. So the masking should work, but I think the values are wrong. You know what? You are absolutely correct, Satcrack. Really good spot. What we should be doing is actually looking up this value. This should be the X value. Like that. No, I don't need to transfer that. Yeah, that's correct. Good spot. Very good spot. So that should be perfect now. Except something's broken. Oh, damn. What's that? Load. Oh, because now I'm loading X from... Oh, there's so much room for optimization in this. But yeah, now if we... How do I advance? There we go. Cool, that's moving perfectly across it. So all we need to do now is repeat that for the other locations as well. So it's this block of code that we need to repeat. There is so much room for optimization, but yeah, as I say, I don't care about the optimization for now. Let's just get it working. I can work out. So there's lots of like stuff we can pre-calculate that I'd like to move out of these loops.
There's things like these loops and comparisons. We're doing, 16 comparisons. That's going to be. I mean, how many cycles is a comparison? I mean, it's quite a few. Oh, it's only 2, but it's still, that's 32 cycles just for that comparison instruction. So we could get rid of that. We're doing it again here, so it's another 32. So that's like a whole line we could save by getting rid of that per character that we draw. But let's worry about the optimization at a later date. So let's label these top left, and we'll go through them one at a time. So let's do the next one, which is going to be bottom left. I'm going to put that in there because I want to make sure we do this correctly. So this needs to be 28. That gets the one underneath. That gets the location. Then this needs to start char data left. Oh, see, this is awkward. We need to increase this now. Oh, that's fine though. We can do it. Yeah, we can do it like this. So, because this is consecutive data, so this is fine. But I'm seriously going to go through this and really, I'm going to spend some time tomorrow just optimizing, because I don't like how kind of crazy this has got now. +1 that advances the character data on, so this should be fine and give us 2 now. Cool. Alright, that's bottom left. See, look how much code that is. There's a lot there. Let's do top left now. Top right even. So we've gone down 28, so we need to go back 27. No. We're loading screen X. We may as well, yeah, no, we can just start from there. So load, or screen X, just increase by 1. That makes that a bit easier. Put the font up. Char data just needs to increase by 8 again because we're advancing, so that's fine. In fact, for the bottom right, I can just copy this block, change that to a 29. Blimey, that's a lot of code. It's a hell of a lot of code. 278, is that what I typed in? Oh no, I changed my mind anyway. So change that to 29. This advances correctly. Yeah, that should be fine. Yeah, see, look at that. That's quite a lot. But we do have a char sprite moving smoothly across background. You can see what I mean about the highlight. It's not a huge thing, but if I turn that off in the character, we'll get a much smoother look. There won't be any flicker at all. So if I made that blue instead in that character, where is it? Where's my characters? Oh, that is my characters. Where's my character window though? That's turned off, that's why. So I made that blue. Yeah, right, export the... Yeah, just the characters, that's all I need. Yeah, but I mean that's fine. The whole point of this is not to try not to use the character color. And as I say, we could have probably done this using using sprites instead, but we would have run into other limitations. So it's good that we've done it this way. Good night, Jacob. Thank you for joining the stream. The code needs a lot of optimization. It's actually worrying me a little bit now. So like if I add an extra sprite in here now, so we can very simply just just add one, I don't know, part way across, bit down. So we've now got two sprites. So if I try and move two sprites at the same time, and I do one backwards, actually this will be a good test. So if we move one backwards by 2 and back and up by 1, so this is now going in the opposite direction. Actually we'll keep it going, yeah, we'll keep it going in the same, so there's more chance they'll cross over now. You'll see how much sprite time this is, how much raster time taken up. Oh, in fact we've got some weird, what happened there? For a start that needs to be 1 because this is a second sprite. Okay, so this is a routine we need to look at why this is doing this now. Okay, don't cross the streams. Yeah. Okay, so that's doing sprite 0, this is doing sprite 1. Are we doing something weird up here? Okay. Okay, so for some reason adding a second sprite in is causing problems. So let's not move the second one, let's just see what happens with just one. Yeah, so it's doing something odd. But regardless of what it's doing, let's put the move sprite back in again. Regardless of what it's actually doing, you can see that 2 software sprites with this very, very unoptimal code is taking a lot of raster time up to do. And this one isn't even moving. What worries me here. The second one doesn't even seem to be doing anything. Let's try just moving it forward, just in case it is something to do with a backwards movement. Okay, no, the second one doesn't want to move, but you can see it's taken a lot of time. And if we do some more increments here, so we can see just how long each of these things are taking. So now we're increasing the value of the border. For each of these different things, so we can see it'll be white when it's clearing the sprites, it will be red when it moves the first sprite, cyan when it moves the second one, purple when it updates the sprites. I'm betting purple is the biggest block on here. Yeah, look at that, most of it is purple. So it's the update sprite function that's causing the issues. But there's some optimizations there. So for instance, we can, if the position, if the block of 2x2 characters has not moved, so if it's still within the same 16x16 pixel block, then we don't actually need to grab those characters that are behind it again. We could store them. The first time we do it, we could store them. So that's something that would reduce this massively, and then we'd only get spikes of it going up. We can probably do a lot of pre-calculation in tables as well. .cosmos 3, yeah. Yeah, there's a lot. I'm gonna look at this in detail tomorrow and optimize it a bit more. I'm gonna go for a cigarette now, and then when I come back, we'll try and fix this bug because I want to get multiple of them moving around the screen. So if multiple of them are moving around the screen, then I'm happy. I'm also going to grab the tequila. Now we've got something working, I'm going to grab my tequila because I've only got one glass of wine left. It's getting towards the end of the night. Actually, it's quite a large glass of wine. If I did. That would be funny, actually. I release the next .cosmos as .cosmos 3. And then when people say what happened to 2, I can just say, oh yeah, he's just travelled through time, that's all. Right, so I'm going to go and have a cigarette. I'm going to grab the tequila and a shot glass. And then we'll try and fix that bug. Alright, so back in 5 minutes, guys. Cool, I'm back and I got tequila. Are enemies going to throw anything or just players throw stuff? Not decided yet. I guess it depends how efficient we can make this software sprite routine. So quite a large shot glass, so I'm not going to do. I've got no lemon, so this is gonna hurt. Cheers, guys. Ooh, ooh. Ooh. Thank you for the follow, Tim Freund. Welcome to the stream. Oh, I washed that down with wine. Wow. So I was having to think while I was having a smoke, and there's a lot of ways that this could be optimized. So we talked about having it's fine. It's fine for it. Now I've got the code kind of working. I'm happy to kind of have a little bit more. And I've only had one bottle of wine, so it's not too bad. I'm not going to go mad with the tequila. Yeah, I was thinking we talked at the beginning about all the different combinations of where the ball could be. Because it's multicolour, there's only actually 4 positions it can be horizontally before it moves into the next block. And 8 positions vertically it can be. So there's 32 combinations of where that sprite can be. And if you imagine we store that data, so each block of 2x2 consists of 32 bytes. If we store all 32 combinations of that, then we're going to use 32 times 32, which is 1024, I think. That's a nice simple round. No, that can't be right. Is that low? Let's have a look. Yeah, 1024. So we could, yeah, I'm going to do a commit right now, just in case. I'm going to call it semi-working sprites. Commit, there we go. So there is a bug if we've got more than one sprite, it does some weird stuff, but we can figure out that later. So we could actually store in 1K of memory, we could generate it, so we don't have to store it in the 16K. Yeah, you know what, I could do with an alert for commit, couldn't I? I could have like a, you can only use it like once every 10 minutes or something, so people don't spam it, but yeah, that would be pretty useful. Actually, I'm going to make a note of that, because that would be quite useful. Where's my pen? Alright, I'm not going to make a note of that, because I don't know where my pen is. Oh, there it is. I also need a GitHub one as well. And what was it? Somebody else typed one in before. What was it? I know listen is one. I'm going to put that in. Probably need another one though as well. Yeah, so we could store all combinations of those into 1K of memory, and that could be generated with code. So it could be generated in this area here where we do the generated tables. So it wouldn't have to take up loads of memory. It wouldn't encroach on our 16K limit. What I'll probably do is reserve an area of memory, probably from B000 up to C00, where we can store these generated things. Yeah, like the nebulous bricks, exactly. And then that means when we do this, the merging and kind of calculating the data, we actually won't have to do any of this shifting stuff that we were doing. So where we were trying to draw the character, shift it down, shift it across, we wouldn't have to do any of that at all. And then that, I think that would save quite a lot. So I mean, if I take that out, if character horizontally, yeah, so if I just take that out and imagine that this isn't happening, let's have a look at the difference to the left column. I don't know if this is even going to work, because I'm just randomly commenting out blocks of code now. And see, that's taking up a lot less space. Hell of a lot less space. I mean, obviously it's not working properly now because we don't have the correct data to do the masks from. But you can see that is a lot of the data is drawing that bit. So if we have already had that, then when we come down to the bit, when we come down to this bit where we're doing the kind of oring of the data and masking of the data, we'd just be grabbing it directly from our lookup table. So that's one optimization I thought we could do, and that would make a lot of sense. That does kind of limit how many different kind of things we have, because each one of these would then be 1K. So every time we add a new projectile, it's another 1 kilobyte. I'm not too fussed though. I think that's all right. So a 16K game, if it's compressed and then unpacked into memory, is probably going to be about 40K, 40 to 48K. So that leaves us 16K of memory that isn't being used. Now, some of that will be screen RAM, some of that will be just screen and color RAM, things like that. They'll already be taken up, but it's still going to leave us probably about 12K of memory that is just not going to be used if we go for 16K. So it could be an easy way of optimizing that, and I think it's something we should probably look at. So maybe that's something I'll look at after the stream. Maybe it's something we can do next time. I don't want to do too much code off stream. I don't mind optimizing what we've got, but something like that should probably happen on stream. So there are 64 of them, you know. 64 of what? I believe or both. Yeah, I'm not sure what you're on about there, Akbin. Alright, let's see if we can fix that bug. So if we have two characters, we run into problems. And we run into problems when, I'm guessing when we, well, let's see, let's take the clear out. And let's take the update out. I can't imagine the move sprite's causing a problem, so I just want to see if moving the sprite, it shouldn't do because it's just moving values. So 64 of 1Ks, yeah, so yeah, that's not causing any problems at all. So the move sprite isn't an issue. Let's introduce the clear sprites. Also not an issue. So it is our update sprite. It would be the bloody long one, wouldn't it? Yeah, there's something going wrong when it's looping over. Because see, it's not even doing anything with the second one. So this is sprite 2, and it's not updating it at all. So, it would be the biggest function. I mean, this function is what? I mean, it starts at line 132 and runs all the way down to 358. So it's like 230 lines long. There's a bit of white space in there, but it's mostly just taking up shitloads of memory. Okay. I'm hoping it's not a clash between these, because we do call this function, which I'm actually going to move down to here so I can see it alongside. Sets vector 5, which is original data, which is fine. That's what we're using. Temp 6 isn't being used anywhere else in here, so that's fine. So it's always good to check clashes like this first. We've also got this one that we use in draw, which is using temp 6, but it's only using it temporarily during this draw. So, and that happens here, and the font lookup happens here, and it is a temporary up here. So yeah, it's not being used. Yeah, so it's not a clash between the things. So this is what's skipping through our values. So let's imagine none of this is running. We go to the skip. Okay. Let's just increment and go into the next one. Hi Porker911, welcome to the stream. Yes, it's Sublime, Kickassembler and Vice. The char editor is Charpad. Let me drop a link in the chat for you. It's from Subchrist, I think. It's this one here. Yeah, I'm thinking something is messing up the X in the loop, so let's have a look. So the thing is we're grabbing it back from here. No, I'm just wondering if something in here is breaking it, but it's not. Nothing in here is touching the X. We're just using it here to grab the start value, which is fine. Screen row, it's vector 4. Just make sure that's the same in here as well. It should be fine though, because it's using the same screen row vector 4. Yeah, that's fine. And we're storing the X at this point. So we're storing the iterator. It's still the iterator at this point. And we're continuing through. What I'm going to try doing now is I'm just going to break the loop so that it only does one and see what happens. So see if it's just the fact of having that second sprite around causes the issue. And it doesn't. That seems to be fine. What I find interesting is it's doing some kind of odd thing here. I'm gonna move this raster down so that this encroaches on this area and see if we get the same effect. I just want to see if it's because something's happening here, it's not changing things properly. It could be that it's to do with this area not being reset in time. But the thing is the second sprite isn't even moving, so that kind of worries me a bit. I'm really happy with how that's moving over stuff though. That looks really good. It looks like a sprite, and I really like that. That's nice. And considering I've only ever done this to this level once before, and in fact it wasn't even to this level. So in Parasol Stars, it only ever moves in a 1x2 block or a 2x1 block. So the sprite's either falling or moving horizontally. It never moves diagonally. So it's only ever using 2 blocks, and it only ever moves 4 pixels at a time. So it's either completely in a block or it's halfway between 2. So this is a lot more advanced than what's in Parasol Stars. And Parasol Stars took me a while to optimize. So the fact I've managed to do this in what 3-4 hours is it's kind of good. Quite impressed with that. All right, so I'm gonna move that. I'm gonna move the raster. I just want to see what happens if I make the raster, because I don't want to mix up what's happening with. Let me show you again. I don't want to mix up what's happening with this kind of weird glitch at the top, this here, because it seems to be completely related to this. You know, it's absolutely in line with this. This isn't moving, but this is completely in line with what's going on the screen here. So it could be that this is actually working correctly and that just the move sprite isn't working, and this is a symptom of something else. So I just want to check actually. So we do this routine. Yes, so we do this routine and then we start setting the border back. Then we set all the screen controls back. So I think this actually is happening at the wrong time. This actually needs to be happening on an IRQ. So this is a problem. So let's fix that thing first. So let's go into our IRQ function, which is, I think it's in utils. There it is. And we've got our main IRQ, and our main IRQ is doing all the stuff it needs to do, and it's not changing anything. It's just immediately exiting and going back and basically calling this again. So we've only got one IRQ. So I'm going to make another IRQ. I'm going to call it I'll just call it second IRQ for now, it doesn't really matter. And in this, I'm going to do this block of code here. So what we're doing in this first piece is we're doing our color ramp that was happening in, hang on, let me just undo that. Do that. I can redo that, it's fine.
So our first IRQ is doing this bit here. But when this is finished, it sets a flag, and then that flag says do everything else outside of the IRQ. So that's the bit that's doing all this kind of movement. It's allowing the characters to move around. It's allowing the sprite to move around. But the problem is at the end of that, we're setting the background back to black. So because we do this color shift through here with the background, originally at this point down here somewhere, we were setting the background back to black and all the multicolors back to normal. And that was what was making this look fine. What's happening with this flickery bit here, this kind of weird glitch, is that we're doing that too late. We're doing it at the end here. So instead of doing it as part of the flag, we're now going to do it as part of the IRQ. So we're just going to set another IRQ that happens after this one, which is here. So I'm going to just copy. So we need to acknowledge the interrupt when it's finished. We need to restore the state, return from interrupt. We need to store the state at the beginning. Whoops. Now what we need to do this time is, before we finish this IRQ, we need to get new values. So we're gonna do this in here, and we're gonna point to second IRQ. And we're gonna do point back to the main IRQ at the end of this function. So the only other thing we need to do is set the line. So in this case, the main IRQ fires at this point, so which is line E2, which was where our split began for the color shift, with this bit set to 0. So this bit 0, D0, bit 7 of D011. Why is that not picked up? It's fine, scroll up to it. Bit 7 of D011 is basically the 9th bit, or bit 8 as it's called. It's actually the 9th bit, but we start at 0 of the raster interrupt. So the raster interrupt goes from 0 to 256, and then depending on whether it's PAL or NTSC, it does some extra stuff down the bottom. But to do that extra stuff, you need to set this bit. So for the initial thing, we don't need to set that bit, so we AND it with 0. But for the other side, we don't need to necessarily do that there. We can do this. We can restore everything back at the top of the screen, basically. So back at the top of the screen before we exit the border. I mean, right at the top of the screen, basically, which is 0, 0. We can fire this interrupt, which just sets everything back. So this should actually clear the problem we were having with the flickering. So there you go. We've got rid of that weird flicker at the top now. So we're still seeing this flickering around, but that's just because it's a soft sprite routine. And so we know that the software sprite routine for this second character had nothing to do with what was going on here. It was just bad kind of planning with the IRQs. And that's actually slightly neat to code. It should be like that anyway. If you do something in an IRQ to change character modes and stuff, you should probably use an IRQ to put them back again as well. If you start trying to do it with a piece of code that's triggered from a flag, then you're going to get problems. Code lag from that end. Is FluBits being funny? Let me know if you're getting problems with FluBits, and I'll disconnect and reconnect, and it should hopefully update properly. See, that extra tequila has put me in the same state I would be after maybe 1.5 bottles of wine, so I'm glad I've done that. So that makes me think that actually the problem is not the drawing of the sprite, but actually that moving the sprite doesn't do anything for anything other than the first sprite. So let's have a look at the move sprite routine, which is this one, and have a look what's going on. So this looks like it should be doing the right thing. So
when we move sprite, we give it an X and a Y that we want to move by, and we pass the accumulator as the index that we want to move. So the first thing we do is we store the Y, because obviously we're going to use it as the index, and we transfer the index into Y. Then we load the accumulator away. So basically we're swapping the A and the Y around here. And then we add the Y and store it using Y as an index here. So this should be doing the right thing. This should be updating the X and Y. So we can check that if we, let's just put a thing on here. So a common pattern I do is I do star equals star, which means it actually means nothing in terms of the program counter, but it allows you to stick a label after the end here. And the reason why this is useful is because of this map in here. So when I compile this now, if it will compile, I can see that location now. So it's just a way of me finding out where that location is, without me having to go and search for it at runtime. So now I can check to see if the values in 105A are being updated. So we know the first one is, because the first sprite is moving around absolutely perfectly. So let's... Oops, I should have left that running actually. Let's take a look at that. What was it again? 105A. Okay, so I know you guys can't see this very well. It's really, really small. How does that look on mine actually? Yeah, that's really hard to see. So I'll just tell you what's in that as it comes up. So it's saying that the Y positions are 6, 0 and 5B for those two sprites. So let's advance a frame. So press go and then monitor again. And now it's saying that they're 3C, 3.7. So you can see actually those Y values have updated. So this just isn't drawing in the correct place. So this sprite is not drawing in the correct place. It's not updating at all. Okay, so let's go and have a look at the draw sprite routine. See if it's something going wrong in there. Get rid of that label now, we don't need it. We know that data is updating, so the move sprite is actually updating the correct thing. I mean, it should do. It's a very simple function. There's not a lot going on. Excuse me, I need my inhaler. Okay, oops. 1 second. Okay, that's fine. So let's have a look at move. No, not move, draw. Okay. So this is where it's drawing. So let's stick a breakpoint in here. So we're going to check actually that the... What do we need? We need the X register. We need to make sure that this X register is correct when it comes in. So this should be 0 or 1. 0 or 1. It should alternate between those two. If it's not alternating between those two, then this is why we've got a problem. So we've done a break. Again, you can't really see that, I'd imagine. Yeah, it's very small, but this little window with the red numbers in, you can probably just about see the X under there. So it's at 0, 0 at the moment. If it's okay here, yes, sprite commit. Yeah, I'll commit in a minute. I'm alright at the moment, so if I start feeling a little bit woozy, then I'm going to commit again. But as soon as I get this bug fixed, I will definitely commit. Okay, so the X register is 0, so we're going to advance one until it breaks again. And now the X register is 5, so this is interesting. We've gone into this routine, and yet it's telling us to draw sprite 5. So this is our problem. So let's just advance again and see what happens. So X is 5, X is 0, X is 5, X is 0. Okay, so it's instead of doing 0 and 1, it's doing 0 and 5. So our problem is when we run the draw sprite routine, when we jump into this, X is the wrong value. And that is coming from here. Now, what's interesting here is we should be loading from the temp
value, and the temp value is, oh, it is a clash. Temp 3, right? So we're using temp 3, and we're storing x at this point. X is still correctly our, is it correctly? Yes. So this is correctly our index here, because our index is started here. We don't do any changes. We don't do any changes. This is all just accumulator, still accumulator, still accumulator, and it's stored here. So either something in this lot here is battering this value, temp 3. Let's just check that temp 3 is different value to everything else. It is. It's 0.4. And nothing else is changing that value. Nothing else is using temp. Was it temp 3? Interesting. Okay, I'm going to try something else. I'm just going to see if it is that value. So where we store it, where is it? Instead of storing it here, what I'm going to do is I'm going to transfer it to the accumulator, and I'm going to push it onto the stack. And then down here, I'll leave the store x temp, and it doesn't really matter. It's just a temporary thing. And then here, I'm going to pull it back off the accumulator and transfer it to the x, and I'm going to see if that makes a difference. If it makes a difference, it's just a clash between the temp values. Why is that not right? Oh, because I need to close that. Keep the break in. Okay. So we've got 0, 5. Okay, so for some reason, when it adds a sprite, it's adding it at sprite 5. That's interesting. So this is incorrect. So let's just check to see that it's actually cycling through those numbers correctly. I mean, it should be. Let's check the add sprite routine. I think the add sprite routine is doing something funny. So our original code to store the x in the temp was correct. I don't think it's being bashed. It's just given us the wrong value because for some reason we're getting the wrong value here. So I'm going to stick some breaks in here. So where we create the characters, remember we were returning the value in the accumulator. So I'm going to stick a break in here. I'm going to stick a break in here as well, so we can check the value in the accumulator, and we can see what index it says we're at. And I would expect this to be 0 and 5. So first of all, the accumulator is 0, that's correct. And then the next one is indeed 5. So it is saying that this is at sprite 5. So I'm pretty sure if I was to change this down here, so this is the index of the sprite we want to move, this one here. I'm pretty sure if I change that to 5, it's going to work. Because we're actually moving the correct sprite in memory. But that means we do have a problem with our add sprite routine, so we'll go and check that in a minute. Oh, I've still got another break in. Let me find that other break. There, in here. There it is. Now I can't even see the other sprite. Okay. But it's not there anymore, so we've done something to it. Is that because I'm still doing one sprite? It seems to not be doing multiple sprites. No, they shouldn't be on top of each other. They're in different locations. I mean, they're moving in the same direction, but they're in different locations. Oh, because I'm not actually adding it. I deleted the add sprite. There we go. Yeah, there we go. So now we've got two sprites moving across the screen. So this means our problem... Oh, there was a bit of a flicker on that. I don't know if you saw that then. Ah. So that flicker is happening because this routine here is starting
to do its stuff on the screen, and in this routine we're actually drawing to the screen. So the best way to actually run this routine would be from this point here, or somewhere around here. But that's fine. That's not a huge problem. It's probably more of a problem because we're clearing the sprite. If we change the clear sprite so it happens as part, so the same way that we move the draw sprite to happen on the update sprite, so you update the sprite and then immediately draw it, we could do the same with the clear as well. We could do clear, update, draw, clear, update, draw. But as it stands, this is fine. I don't mind a little bit of flickering like this, especially as I'm going to optimize the hell out of this if it doesn't happen. This is fine. The problem we've got at the moment is in our soft sprite routine, our add sprites is doing something incorrect. So X is our current sprite index, which is correct. This is the one that we want to increment by 1 each time, and we're incrementing it. Oh, hang on. Load X with the current sprite index. Store Y. There we go. It's as simple as that. One character. And now this will pause again unless I do that. So now it should be sequential sprites. Yeah, there we go. That's the problem. So the only problem we've got is this flicker. The flicker is happening because as that sprite is trying to be drawn, it's actually it's happening on screen. So sometimes we're getting it kind of being cleared, sometimes we're getting it being drawn. We're getting a kind of half state of it. So we see a bit of a flicker as it happens. The optimization should fix that. One thing we're also going to do is we're not going to keep this kind of fade that's running through here. It's nice, but I don't think it needs to be in here. It's kind of a bit unnecessary. So I'll move that out of here. Actually, I wonder where that finishes. That must be... We can probably fix that flicker just by moving this second IRQ. So if I move this IRQ to there instead by adding a 1 on there. Now either this is going to happen way too quickly. That didn't seem to do anything. Wait a minute. It's because... No, that's just moved the shift. So I need to change... Wait a minute. This is setting the performance flag. The performance flag is being checked here. And then it's doing all... Oh, okay. If we move all the player stuff to be at the end instead, that should help a little bit. So it was doing all the player collision and drawing beforehand. If we do it here, it should flicker a little bit less. Yeah, there you go. The only problem is now you're probably going to get a little bit of flicker with the player in some certain circumstances. Although it's not doing it, seems to be alright, so it's fine. But yeah, that's made a difference. So we've got this bug over here. I'm not sure what that's about, but for some reason I can jump. Oh, I can see what it is. It's because it lets me move left, but too far. So my players, you see my player's right foot, it's sticking into the wall. So I need to just oh, I don't know what happened there. I guess it's because the ball crossed past me. Ah, yeah. So this is the other thing as well. So now what's happening is the collision is going to be based on these new characters. So in most cases, these balls are just going to splat against the wall, so it won't be a problem. But if they pass through the floor where I am, try and catch one as it goes past. Because they have a collision of, you can see it, I just kind of dip a little bit. Because they have a collision of not solid, I start falling until they go past. See it? But that's not a problem. Colour flicking on Hazy's not gonna like. Yeah. Alright, so I'm gonna try and fix this collision first. So this is gonna be a really simple one. So when we check the right hand side, we just need to move it back like 2 pixels or so. So first of all, I'm going to get rid of all that border stuff because it's kind of annoying me now. I'm going to definitely put it back at some point when I do the optimization, because I want to see how long it takes. I think I can get that down to a quarter of what it's doing now, maybe even less. This routine here is very heavy. As I mean, it's to be expected. It is a kind of, it's a software sprite routine. It's not easy to do and take shitloads of, and not take shitloads of cycles. See, this is why what Barbarian did is very impressive. Okay, let's have a look. What am I doing? Let me have a look at that collision routine. So player, this was quite simple. We'd set up the player to have 2 pixels on the side, on either side, and we just did some here we go, get collision. So get left collision, it's the right collision, so we just need to move this over a little bit. I think 2 pixels should be enough, so I'm just going to move it over. I'm just going to move it over 2 pixels. I think that's probably going to be enough, but check. Yeah, there we go. And now I can't jump up the wall. Oh, but that's because the ball. See, when the ball goes past me, I can actually fall into the wall because it's for a split second. It thinks it's not solid anymore. But that's fine, because what we'll do is we'll add some collision to these so that when they hit the floor, they do that splat, and so basically when this hits the floor, it's going to change the color of these blocks here. It's going to disappear, change the color of the blocks here. It might change into a kind of little animated sprite as well or something. I'm not sure. I think it's probably just enough to change the color though. It will look all right. Cool. This is looking pretty good actually. I'm gonna stop it going off the edge of the screen. I just want to confirm that this kind of weird glitchy stuff that's happening here is just because it's going off screen. So let's have a look at those now. I'm going to temporarily put it in the move sprite routine. So when the sprite moves, I'm just going to, if it reaches an edge, I'm just going to wrap it round to the other side. So in, where was it? Move sprite. Okay, so we've got sprite data X, LSB, and so let's do the Y first. So we need, what's the Y going to be? So we've got 11 rows of tiles, so that's 22. 22 times 8 is 176. So we need to compare it with not 176 but 168 because it's 8 pixels high. And if it's less than that, we can just continue. Otherwise, we'll load with 0. It's going to be a bit trickier here because we've got 9 bits. So we'll do the calculation, then we'll check. So first of all, if this is 0, we can do nothing. We don't need to do anything. If it's not 0, then we need to check this value. So no, not this value, sorry, this value. So our screen is full width, so it's 320 pixels wide, so we need to check 320 minus 8, so that's 312, minus the 256 from the first 8 bits, so that's 44 plus 12, 56. So we need to compare with 56, and if it's less than 56, jump to there. Otherwise we need to put 0 into there and into there as well. Okay, I need to wrap this actually because this is kind of temporary. Or is it? I mean, I'll treat it as temporary for now, but this is probably something with remove eventually. I mean, there's no point in it wrapping around. Play projectiles shouldn't be wrapping around, I don't think. Okay. And yeah, I will commit. Really good idea. So let's just have a look. Yeah, and we're not getting any glitches now as they. Cool. Right. Yeah. Very good idea. I mean, I'm going to commit. I'm going to commit, and I'm going to celebrate with another tequila. So. I'm quite pleased. I knew this wasn't going to be easy. I knew it was going to be complicated code. I knew it was going to need a lot of optimization. I actually wasn't confident that I was going to get it all done in one night, but it seems to be working quite well. What I'm going to do now actually is I'm going to reverse the direction with one of the balls. Although, saying that, I'm only checking the I'll reverse the Y direction of one of the balls and then put them on the same X value so that they do cross over. So let me set their X's to be the same. Just slightly offset so they do cross, but they're not exactly the same. And then I'm going to change the Y direction. I just want to make sure that they work on that. And yeah, any shape should work now as well, and they should be able to cross without leaving any issues as well. Cheers, guys. That's it. I'm out of wine. I'm only down to tequila now. So. Oh, okay. So the problem I've got here is I'm only wrapping it on in one direction. I need to let me wrap the Y in the other direction as well. Oh, that hit me in one go. Wow. So I'm gonna make this work so that they cross over. Then I'm going to create another character with a slightly different shape and a different color, and see if they work together. And then that kind of covers most of it. I might add a third one in as well, just to test a third one. After each commit, I can have another shot. Thank you, Akmafin. It's very kind of you. Yeah, see, this is a problem. I'm going to put that to 169. That might actually fix it. That might be enough. Optimization tomorrow is an optional thing. If I can do it, then fine. If not, fine. No, it gets stuck at the top. Oh yeah, and that does make... Alright, I'm going to leave the glitch in, because I can deal with the glitch, that's fine. Whoops, don't want to delete that. I'm going to get rid of this temporary stuff. I'm gonna just gonna let it glitch for now, just so I can test it going the other direction. They seem to cross fine. They don't leave any remnants of each other behind, which is good. Yeah, they're crossing absolutely fine. Yeah, it's the multicolor. So the whole point of doing it like this is to use the multicolor. That's why we're not getting any color clash. So, I mean, I'm sure you guys have seen Spectrum games before, and this is the problem that Spectrum games have. So because they only use one color per character block, and they use a system like this, where they use software sprites basically. They have the problem that if you've got a software sprite that's one color and you move it over another area, you get color clash. So to avoid that similar system, I don't want any game I ever write to look like it's a Spectrum game with more colors. I don't want it to look like that. So I'm trying to use multicolor values. So we could change these values to be blue as well, but that is kind of the sky color, although there will be some more background around there. Can we do a black border around the ball? We can, but we have to change the way the masking works. So at the moment, the masking works based on solid pixels. What we'd have to do is change it to work based on the transparency as well. So the background is actually black. So at the moment, if I put a black border around the ball, you just won't see it. It'll just disappear because it will be masked out by the foreground. We can change the masking routine to do that, and I think that's probably what we'll have to do at some point. Just thinking, is that something I can easily do now just by changing the table? You think? I think so basically what's happening is, right, we've got, as I said before, we've got these these pairs of multicolors like this, and all it's doing, the mask is looking to say any of these one. So it can be that, it can be that, or it can be that. And if it is, it's creating a mask like that. If it's 0, 0, it's ignoring it. So one way I could do this, actually, one way that might work is if let's try this actually. Let's give this a shot. So I just want to see if it breaks badly if I change this routine. So the table that I'm doing down here is only cares if any of them are the same, if any of them have a 1 in it. Okay, so that means if it's using char color, and this is on the foreground, we're never using the char color. We never use the char color in the ball. If it's using the char color, it's going to create a mask like this, that's fully masked out. However, because we're never, if we absolutely guarantee we never use the char color, and we just use foreground color, transparent color like that, then what we could do is we could use EOR on it. And if we EOR that, as I said before, it's a new operator that we've not touched before. It's the first time we've used it. This is the result. So now what we'll get is transparency will actually be solid, and character color will be our transparent. So in here, anywhere we put char color on this will be seen as transparent. So what we'd have to do this, make this bit transparent. I'm going to do it all now actually, and then we could use transparency as an actual color, and now our ball would look like that, and that definitely looks different, right? Now let me save that out. And first of all, I'm going to run it without changing anything so you can see what the problem is. And then I'm going to, I think actually, if I just EOR the value, it's fine. All I'm doing is basically saying, okay, the thing you were using as transparent is now actually solid, and the thing you were using as fully solid, 1, 1, is now actually transparent. I think I can do that quite simply. And that actually gives us black as well to use. So then we've got black, green and blue that we can use to form all the different shapes. So you can see it's doing weird stuff now. So now we've got character colours in there. The black is not showing at all. Because it's character colour, we're getting the colour as it moves over the thing. So, right, let's try and change that table. So this is the table. It takes the value in the accumulator. No, sorry. Takes this value. Let's do this to it. And we need to do it again here. Oh, no, that didn't work. Because now it's taking... Oh, damn. So this is because... Let me think. This is because... See, this is why it's a good idea that I've commit. This is because... When we clear the values, so in our draw routine, in our kind of routine here, there's a place where we set 0 on things. Is it this bit? Yes, it's this bit. So we would need to set it to FF instead. And then the same here as well. So we need to start with FF. And I think we need it in one more place if I'm not... Oh no, I think that's fine. It's almost there, but it's taking the character colour and putting it in the background. Okay, think. Why is it doing that? Taking the character colour because we're starting with FF. It's looking up that value in the table. Oh, maybe that table doesn't need to change then. Maybe I just need to do that. Yeah, you see, that's what I'm trying to avoid. I'm trying to avoid it looking like a Spectrum game with a palette instead of a Spectrum game that's all in yellow. I don't know what it was with Spectrum games. They seem to like making games yellow for some reason. Yeah, it was a strange choice. But it seemed like, oh, yellow and black seems to be the combination that people like. Let's just make everything yellow and black. I lost track of how many games I played that were yellow and black. It was intensely frustrating. Okay, let's try that. See, because I'm adding that value, do I need to do it? Hang on. Okay, I'm getting a bit confused by this. I might need to look at this. Yeah, maybe it is because it was the contrast. Yeah, see, that's not what... So... The inverse was correct, but I think there's something else going on with the FF. Oh, wait a minute. What's the... Hang on, is this actually... If one of these moves over an area, do we actually get any of the background in it? Or is it... No, we just get the colour. And then it's kind of all blanked out. Okay. Yeah, it is good that we committed. To be fair, though, I know what I've done here. It's I've commented out the stuff that I've fixed there. They fixed the stuff that I've messed with. This is something I think can definitely be done. I need to think a little bit more about how this should work. Because technically this should be possible. So you can see what's happening here is it's just drawing the character colour. And that's exactly what we've told it to do in here, right? But the problem is where it's transparent, the mask is saying draw the background. So it's drawing the background where these are, and then it's drawing the character colour in these locations. So you can see that pattern. You can see that 2 pixels and then this thing underneath, which is 2 pixels thing underneath. Okay, do you know what? I'm going to go for a quick cigarette. I'm going to have a tequila when I come back. I'm going to give it another 20 minutes or so of trying to do it. And if not, it's one for the next stream. We're looking pretty good though. I think on the next stream we can actually start making the players fire these things. Assuming I can get them optimized in time. If I don't manage to optimize it through the week or tomorrow, then I'll do it on the next stream anyway. But yeah, I think we're getting very close to having something where the players can actually jump around and do things. It's going to be interesting. Right, okay, so I'll be back in 5 minutes, guys. Be right back. So, given these 3 values, what would you expect char colour to be? I'm going to pour a tequila while you answer. Yeah, see, that's the thing.
you would think it would be this one, right? You would think it would be charcoal. This would be it, right? But it's not. I think Furrow is right. I think it's 01. So let me just check in the font. Thank you for the follow, Remage. I'll call you Remage. Remage FRS. Welcome to the stream if you just joined. Whoa, that tequila really hits me. I haven't got anything to wash it down with. That's the problem. But give me 1 second. I'm just going to grab a lemonade. Right, now I've got something to wash the tequila down with, because that's better. Right. Yeah, exactly. It's not what you think it is. So I'm just going to double check. So I'm going to open Charpad. Just going to play around with this character here. I'm just going to fill it with white. And then I'm going to export that to the desktop somewhere. I'll just call it test.bin. And then if I open that up in Hex Editor and have a look, desktop, desktop bin. Oh no, it says FF. Huh. Okay. So it's not what I thought. Okay, I take that back. I was kind of convinced that it wasn't 1-1. So Stoker is right. It is 1-1. Okay. So what have we got at the moment? Let's see where we're at. I can't remember what we've done. Oh, right, okay, so we've got this weird situation here. And that's because we've changed the character. But this character is exactly what I want it to be. I want to use this as a transparency. So think about this. Okay, so I want anything that's 1-1 to be 0-0, and anything that's 0-0 to be 1-1. That's what I want. I want these two to be reversed. We don't want to make black our char color because we want these everywhere. So it's not about changing the colors in the map. It's definitely about changing the way the mask data works. But that should work. So when we do this routine down here and we build this table, this should be enough. Maybe it's not FF we need to or it was. So let's have a think. Right. So if we've got 0-0, 1-0, 1-1, 0-1, that's all the characters we can use. We want that to end up being 1-1. Don't care what these are. These can be 1-0. That needs to be 0-0. That needs to be 0-1 or 1-0. I think we can do this with. That's an EOR. That should work. This should work. So why isn't it working? Okay, so why isn't that working? Bit pair 0 and bit pixels, bit pair 0, bit has background, bit pair 0 is one's okay, a bit by bit 0 to 2 of the color byte, yeah. Yeah, so I'm not sure. So if I do this, I should be doing this here. I should be reversing everything, and that should be enough. Because all we're trying to do is create a mask, right? The actual value, whether or not it's multicolor 1 or multicolor 2 is irrelevant. All we're trying to do is switch these two over. So the fact that the bits here switch is fine. This should be enough. Why is that not enough? I'm going to do it again. I need to see exactly what's going on in that case. Right, so we're doing exactly as we were before. We're not doing any kind of clearing in the main routine. So let's have a look. Using trinary, yeah. But it just creates that black. So, well, the black is fine. The black is just because we're using the wrong values when we're clearing the things. But why is that not pausing? Come on. Pause fine. There's nothing wrong with that. Oh, it's because I was pressing control and pause. Okay. Yet for some reason it is still using the character color here. This is because... No, this is not because... Oh shit. Okay, I know what's going on. So ignoring the black rectangle around everything. So what's happening is once we've got our character and we're trying to merge our new character into it. So the bit that's doing this bit here, this value that's in this location is still the original data. It's still like this, right? It's still got the it's still got the character data in these locations. This needs to change to 0, 0. So what I need to do maybe is at this position here, once I've transferred it to the X register, I'm going to then EOR it. Oops. And I'm going to store that. Do I have a temporary value that I can store it in? So I've got a temp there. I need another temp. Let me get another temp. A really good job I did this. We used temp there, so I'm going to add another temp in here for temp 7. It's a really good job. We're temp data, I'll call it. Doesn't really matter. Really good job I've committed, that's what I was going to say. Because I'm doing some kind of rather dodgy stuff now. Oh shit, where was I doing that there? There we go. And then instead of ORing it with the data that's there, if I OR it with this data, like so. So this is just the bottom right. So let's just keep an eye on the bottom right position and see what there's. Now the colors are going to be flipped, so our multicolor values are going to be flipped. Our transparency value should stay the same, our background value should stay the same, even though we've kind of filled it with kind of white where it should be blue. Do you know what I mean? It should look right, but the color in the bottom right corner is going to be a bit funny. Okay, let's pause it. No, it's not right, is it? Because all this is wrong now. We've got none of the black. This color is... What color should that be? Yeah, it's not... Damn. Oh, that's a better one to look at. Let's make that a bit bigger. So I expected that color to be flipped. Actually, no, this might be right. But now we're getting char color instead of transparency here, which is wrong. And that's because we're only flipping... Hang on, let me think. We're only flipping... No, we're flipping those two colors, but that actually needs to be transparency and not char color.
Yeah, it's not gonna. No, you see, the blue is not the background color. This is the problem. The blue is multicolor too. Yeah, I don't think this is something I can figure out at this moment in time. I'm going to leave it as the original. I'm going to revert it now. I'm going to do it without committing, just to prove to myself that I'm not completely pissed. Because I think I need to think a little bit more about the logic of this. I think we can do it purely with this table down here. But I do need to take those out now because they are just breaking things. And I need to revert this character back to be... Actually, no, that should be transparent. So... Actually, I kind of like that as transparency like that. That's kind of cool. Okay. Yeah, manual undo. Manual undo just makes me... No, you see, this is the thing. Multicolor 1 and 2 can switch. That's fine. And doing an EOR on those values will actually switch those around. So 1 and 0, 0, 1 doesn't matter. I mean, we can always change the color of it in here if it's going to be the inverse color on the other side. That's fine. What needs to switch is 0, 0 needs to become 1, 1 and vice versa. But the problem is because we're using a mask as well based on this, the mask needs to actually treat 1, 1 as 0, 0 and 0, 0 as 1, 1. But then the additional problem is then when we try and draw that back, we need to actually take into account when we're drawing back the original sprite, and we do the OR of the original data. The data that we OR back into the on top of the background also needs 1, 1 and 0, 0 switching around. It's kind of an awkward thing to do. I'm absolutely sure we can do it, and we definitely should do it because it makes a hell of a difference. That black outline really makes it look nice. Yeah, okay. So yeah, we should do it at some point, but right now I don't think I can think straight enough to do that, unfortunately. Right, I think I mean, we've got the collision working over this side now. I'm going to check it for the second player actually. So no longer can walk up that wall, which is good. Just make sure player 2 can't do the same thing. Actually, we'll be able to. So we need to fix that. So let's go and fix that. Because it's 2 separate collision routines. So what do we change it to? 13. Yeah, 13. So this is player 2. Left collision, right collision. Oops, 13, there we go. Yeah, I think I just need to sleep on it and look at it with a bit of a clearer head. I think I'm... Can you set the material on the ball chart so the bees... Actually, that's a really nice point. So in Bubble Bobble and Parasol Stars, you can jump on the things. So actually, let's do that. I want to do that. So, so all we need to do for that is go save that. Is go into here and change all of these characters to be material 1, and now we should be able to jump on those balls. It's character set attributes, so it's the colours, and that should actually do it. It's going to be hard to time, right? But you should definitely be able to jump on these now. Yeah, there we go. Again. The thing is, though, is you're not going to get pixel perfect collision on these because they're moving across 2x2. So you're going to jump on the whole 2x2 grid, not the actual ball itself. I'll leave it in for now. We can always change it if it feels wrong. It might be we can add some extra things into it to deal with the offset of it. So if it is a if it is one of the projectile sprites, then we can actually use the offset as well as a thing for calculating the collision. But yeah, you at the moment you can jump on them, but there's up to 7 pixels of inaccuracy. So that could make for some interesting gameplay as well. So you could have some. I mean, it's the same in Bubble Bobble actually. There's some levels where jumping on the bubbles is the only way to complete the level. I'm gonna have another tequila. Why not? Okay, this is my last one though. Okay, I'm gonna commit what I've got so far, including all the assets, because I think it's I don't even know what to do now. What did I change? Let's have a look. Apparently nothing, but oh, they're binary files. Okay. It's a collision fix for player 2. There we go. I'm just going to double check player 2 is actually working correctly as well. All that pushes. Yep, so player 2 doesn't get stuck on the wall now. You won't be able to throw a yellow ball that splats and turns the ground yellow. We can make the ground yellow but not the balls. Oh, that's a really good point actually, Farai. Yeah, that's a very good point. We need to make... Yeah, that's it. It's a very, very good point. So either we need to build... Either we need to not have colours representing the projectiles themselves, but we do it with shapes. In fact, I'm going to add a third shape in before I end the stream. Or I'm going to add an extra shape and a third projectile. Or we need to make sure that we need to add color RAM updates and make sure that the background only uses the multicolor values. I'm not sure on that. That's something we should probably think about in the next week about kind of how we do this. So, cheers, guys. What I'm going to do now is I'm going to add in a third sprite, and I'm going to add a new shape in as well. I don't know, I'm just going to do... I don't know what to do here. Let's do it... No, let's not do a char colour. Let's do it like this. Let's do a cross. That should be fine. Let's just do that. I just want to see what happens when I've got two different shapes crossing over. Yeah, we do need that black. We definitely need that black. We make enemies with chars. That might be a bit hard. The thing with these sprites is these software sprites is they're just 8x8 characters, which means we only have to update maximum 2x2 characters. If we did enemy sprites, then we're looking at the very least 2x2 characters, which would mean you'd have to update a grid of 3x3 for each enemy. It's not impossible, but if you start adding animations into the mix and stuff, it's probably going to be a little bit much. BCD score should be a little bit easier than tonight. Oh yes, definitely. I'm still not entirely convinced we're going to do BCD score anyway. I don't know. I've not kind of decided yet. We'll think about that when we come to it. One other thing I've not done yet as well is you guys gave me a lot of names which I put into a file somewhere. I think was it in the README? No, it wasn't in the README. In the design, and I've still got a list of titles that I need to take from Acmafin's list. Well, 2 players, 2 balls, and 4 monsters max at once. I think we can make this work. I think we can make this work with character sprites. Yeah, I do need to, you suggested a lot in the chat, so I'm going to pick out probably 5 or 6 of those that I think stand out the most and put them in. And I'm going to create this list a bit as well. If I can get it down to like 32 maximum, then that kind of creates a nice tournament situation where I can make a few votes on Discord until it gets down to 4, and then make a Twitter vote with the final list. Yeah, I mean, I see where you're coming from, Furo, with the stuff. It is a little bit worrying. I didn't think of that actually. That it's a bit of a problem that we want to have the ground change color, but we don't actually have a way of coloring those projectiles properly. Yeah, 2 players, 2 balls, 4 monsters. The problem with that is then you're limiting the player to firing one thing at a time, and that kind of makes it feel a little bit limited. 4 monsters is also not that many. That's gonna seem... I want the game to feel kind of hectic. It could simply be that the projectiles themselves, the color of them is kind of consistent, but it's the shape of them that matters. The shape can be quite descriptive, so the shape could be, you know, like a I don't know, but we can use the shape to define what they're doing. So yeah, Pick and Mix is a good name. I did like Pick and Mix. The problem with Pick and Mix though is it's a very British thing, as I found out on the last stream. When somebody mentioned it, a lot of the non-English people didn't know what it was. So maybe modify the character color or sprite depending on what projectile I have at the time. Yeah, I mean it could simply be that the player itself changes color. Yeah, I mean there's a few ways we need to do it. It's something we need to think about. But I definitely agree we need to think about how we're gonna implement that. Game like Donkey Kong works, anything can. Yeah, the thing that makes Pick and Mix so good is that for an English person it makes a lot of sense. When you hear Pick and Mix, you immediately think of sweets, and so you think, oh, if a game's called Pick and Mix, it's going to be about sweets. You want that same feeling for everybody that plays the game. You don't want to limit it to just one country, really. There was another one in there as well. Which one was it? There was another something and something. Not Sweets and Goblins. Oh, what was it? Oh, maybe if not, got it in here. I really liked Sweet Fighter. I thought that was brilliant. The only problem is there isn't really any fighting unless we kind of really amp up the 2-player thing. Maybe Crash. Yeah, I think those are my 3 favourites: Sweets of Rage, Sweet Fighter, and Pick and Mix. But I'm going to leave it to everybody else anyway. I'm going to take the ones that Acmafin's put into Discord, create a list of about It needs to be a nice round number for kind of for tournament purposes. Then I'll whittle it down to 4 with some votes on Discord and put it to a vote on. Oh wait, maybe it was that one, Andy and Mandy in Candyland. I don't know. Yeah, Gummy. I liked Gummy Gobble, except for the fact it made me think of horrible, nasty things. Delete Sweet Wolf. Yeah, I liked Andy and Mandy. Andy and Mandy worked. Andy and Mandy in Candyland has got a kind of ring to it. Yeah, it's kind of cool. Right, let's add this third sprite in, and then I'm going to call it a night. I think it's getting quite late now. It's like 3 AM. So let's go into here. Let's just add a third one in. Let's add it in a slightly different location this time. Let's set the carry bit as well. Why not? We've not tested that. And we're setting 181. And then in here we just need to update the same. We're gonna move the sprite. This time it's sprite 2. We'll move it backwards instead. We'll keep that direction, that's fine. Maybe we'll move it a bit faster so it's moving at a different angle. Oh, thank you for the raid, Mr. Cola, and welcome to the stream, guys. We're probably about 10 minutes away from finishing, but yes, thank you very much. What have you been doing tonight then, Cola? I was watching one of your streams the other day, and I'd never seen the game before, and it made me want to go and play it. I think it was oh, what was it now? It was Check's Quest or something. It looked really interesting. It looks stupid but fun. It made me want to play it. Which I don't know if that's a good thing or a bad thing. I think Chex is like an American snack, isn't it, or something? But it kind of meant very little to me, but it looked like an interesting kind of Doom style game, so... Ah, okay, yeah. Yeah, it looked like a Doom mod. Not seeing a third sprite. Where's the third one? 1, 2, 1. Oh, there's something very weird going on there. I don't know what's going on there. Let's try this. Yeah, I watched you play that the other day, and I thought it was quite interesting. I'm only seeing 2. Oh, no, there we go. We've got 3, but what is going on? There's something very odd going on. This might be one for another day. I don't think I can handle this right now. You know what? I am going to have one more tequila before we go. Why not? Yeah, it looked really stupid, but it looked a lot more fun. It looked interesting. Like, it looks like you could get excited about it, and that's a good thing. Cheers, guys. I'm actually almost out of tequila. That's kind of impressive. Ooh. I kind of want to play Parasol Stars. Should I play Parasol Stars? Maybe that's what I need to be doing right now. Maybe I need to finish on half an hour of having a go at Parasol Stars. You know what? I'm gonna turn it on. And the button. There we go. Why not? Do you know what? I'm going to go for a very impromptu cigarette because I've had tequila. I'm going to delete this little routine. I'm just going to make sure it all works as it is, which it seems to do. I'm going to delete the additional update in here. And then I'm going to commit the code. I'm going to go for a break. And then when I come back, I'm going to do something a little bit different. Oh, there is nothing to commit. It's just, in fact, I'm going to discard that. It's not even worth saving. It's just some white space.
And when I come back, I'm going to attempt to get the Amiga on. I think it should just work. If it works, then I'm going to give Parasol Stars maybe half an hour to an hour a play before I quit. So I'm going to go for a cig, guys. I'll be back in about 2 or 3 minutes.